I'm sorry, my dear students. I'm sorry for the late. Good morning, all of you. A very good morning to everyone. I hope you people are doing good. I hope my voice is clear for you. Very good morning to all of you. Now, let's start our session. So, yeah, okay, fine. Let's start our session. So for the same problem with me, the login details have been some sort of problem it has created. So that's the reason why it became late for me. So some login problems were there. That's I was resolving those. Yes. So now, a very good morning to all of you. So meanwhile, I just want to explain one more problem. So you please look over here. I hope you people have done the previous homework. I have given you two problems as a homework. So one is the previous IES question and one is our GATE means classroom practice question. Now let's see one more problem regarding to that. Now you see, everybody have a look. A clay specimen when tested in a unconfined condition gave an unconfined compressive strength of 100 kilonewton per meter square. So a clay specimen, soil is clay and unconfined compressive strength is given as 100 kilonewton per meter square. You know that unconfined compressive strength is nothing but 2 times of Cu. 2 times of Cu. Okay. Now, a specimen of the same clay with the same initial condition. What is the meaning of initial condition? Unconfined condition is same condition means the soil is going to be clay. So you know that in the case of clay, phi u is equals to 0 degrees. Now it is subjected to UU test. What is the meaning of UU test? Unconfined, unconsolidated, undrained test. See, when you conduct a UU test on a clay soil, phi is equals to 0 or not. So now, under a self pressure of 100 kilopascals, axial stress at failure. The meaning of axial stress is a sigma 1. The meaning of axial stress, axial means total vertical stress. If I would have asked a deviatoric stress, then it should be sigma d. Or if I would have asked additional stress, then it would be sigma d. So now I am asking you sigma d. So what is sigma 1? You know that sigma 3 is equals to sigma c. And from plastic equilibrium equation, condition, sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. As phi u is equals to 0 degrees, alpha f is 45 degrees, which means sigma 1 is equals to sigma 3 plus 2cu, because that UU test, right? UU means undrained. Undrained means Cu and phi u. Now you see already 2Cu is nothing but Qu or not? 2Cu is nothing but Qu. So what is sigma 1? Sigma 3, which is going to be 100 plus 2Cu. What is 2Cu? 100. The answer is going to be 200 kilopascal. 200 kilopascal. So the answer is going to be 200 kilopascal. Mind it, I have given you which strength? Compressive strength or shear strength? Compressive strength. If I would have given you as a shear strength, then Cu is going to be 100. But I have given you unconfined compressive strength Qu, where Qu is equals to 2 times of Cu. So now from the plastic equilibrium condition, as you know alpha 45, then sigma 1 is equals to sigma 3 plus 2 times of Cu. And what is 2 times of Cu? 100. 100 plus 100 200. So that's about the test regarding to this one. Now I hope you understood. Now let's come to the vane shear test. See, this vane shear test, it can be either field or lab test. It can be either field or lab test, suitable for saturated clays, especially marine clays. Suitable for saturated clays, especially for marine clays, and loading rate is quick. When the loading rate is quick, you know that the test type is going to be untrained test. Sir, how does this looks like now, sir? See, everybody, I have already given the figure over here, but if you observe, the figure looks like this one. See, whatever this is nothing but, yeah. So whatever this is nothing but, if you observe what I am showing you, this figure, this is nothing but a vane shear. I hope you can see the blades. This is one blade, this is one blade, this is one blade. And this is the handle you are going to observe. And whatever this is nothing but the blade, and this blade has some height. And now, see, if I show you the same blades, means vanes. We call this one as a vane. Vane means blade. I hope you can see this one. This is the this is the equipment that we use in the vane shear test. Now, if I show the same figure in isometric projection, this is the isometric projection. I hope you people have been able to understand this one. You see, yes. Whatever this is nothing but the dia, and this is also going to be dia, and this is also going to be dia. You see, so this is an isometric projection, and where D is dia of vane, and you see this H is height of vane. And what is this vane shaft? Just now I show you, this is nothing but the vane shaft, and this is the height of the vane, and it has some diameter, dia of the vane. So now what happens over here is, in the case of the vane shear test, what we do is, vane is pushed into the soil. So first you are going to vane, means the vane is going to be pushed into the soil mass, and applies torque. Now you see, by taking this one, this whatever the equipment, now you keep this one, you push it to the ground level. Now you start rotating. When you start rotating, what happens? You're going to create a twist or not. So once you keep it over here, if the blades are going to be goes inside of the soil mass, if you rotate that, then that will shear the soil mass or not? Yes. These blades, when I apply torque, these blades will shear the soil mass, and shearing occurs. So when is pushed into the soil mass and applies torque, and shearing is going to be occurs. So the amount of torque you need to apply depends upon the strength of the soil mass. Amount of torque applied depends on strength of soil. As I said, this is going to be useful for the cohesive soils. Mind it, this is for the cohesive soils. In the case of cohesive soils, what is the strength? Strength S is nothing but Cu. T directly proportional to Cu. So our content is to find out the drained parameters or undrained parameters, means shear strength parameters Cu, phi u. As I told you already, vane shear test is what type of test? Undrained test, which means Cu, phi u. And is suitable for whom? Clays. Clays means phi u is equals to 0. Now, whatever the torque that is going to be applied, this is nothing but the torque. You see, you are going to apply a torque over here or not. When you apply the torque, this will shear the soil mass. This will shear the soil mass. Just like I can show you, if this is a ground level, if this is a ground level and if this is nothing but a soil mass, so then it will shear the soil mass. It will shear the soil mass. In this zone, the entire soil is going to be sheared. So whatever the zone I am writing, in this whatever the soil mass that is going to be gets shear. And based upon the torque that you have been applied, you are going to find out the Cu value as T is equals to Cu into one minute. So T is equals to pi d square into Cu into h by 2 plus d by 6. If d is the dia of the vane, so then whatever the torque you are going to apply is nothing but the pi d square into Cu into h by 2 plus d by 6. What we required is going to be Cu. You can find out the Cu. So here, if total vane is in shear. Total vane means, if you observe this vane, whatever the vane I am representing, this vane has two faces. This is known as top face and this is known as bottom face. So pi d square into Cu into h by 2 plus d by 6. This is the equation that we need to remember. Now, the same T value is going to be pi d square into Cu into h by 2 plus d by 12. If only one face in shear, or if top face is not in shear. What is the meaning of this one, sir? You see, whatever this figure is there, right? If I say this is the ground level, if I say this is the ground level, now you observe whatever the soil below this one will be under shearing. Whatever the soil, just simply you rotate, means you apply the torque. So below the soil will be under shearing. What about the top face? Top face is not in shear. But generally we take the total weight is in a shear. So if they don't mention anything, you have to take this value only. If they don't mention anything, then you have to apply the value as a T value. See if total weight is in a shear. Now, the condition over here. Listen to me. As the amount of torque depends upon the Cu value, yes or no? See, if the soil mass is a loosest state or remolded state, if the soil mass is a loosest state or remolded state, now my question for you is, are you going to apply the torque rapidly or slowly? Rapidly or slowly? If the soil is going to be loose or remolded, you know the meaning of remolded, disturbed soil, then you can keep that device, and you can rotate it rapidly, and the number of rotations also going to be very less. So if the soil is going to be remolded, then the amount of torque required would be less, which means you can apply the torque rapidly and number of rotations are less. Sir, for example, if the soil is going to be undisturbed, I don't want to disturb the soil mass. If I don't want to disturb the soil mass, I have to apply the torque as a slow rotation, and the number of rotations are going to be more. Just think, Nana, you keep a knife in a soil. If you rotate it fastly, what happens? Soil will get disturbed, remolded state. And if you rotate it slowly and gently, soil won't disturb, undisturbed. So for undisturbed sample, torque is applied is slow and more rotations, and for disturbed or remolded, torque is quick and less rotation. Torque is quick and less rotation. Even we rotate slowly, so much of the soil is disturbed. See, some much of soil is disturbed, but the total soil is not going to be disturbed. Just simply, Nana, you take this as a knife. I hope you can see this one. You punch this one into the soil. Now you apply some torque, means you apply some rotation. When you apply some rotation, now when you apply some rotation, now you see, when you apply some rotation, if I apply the rotation quickly or if I apply the rotation fastly, then the soil will be disturbed more. Yes or no? But if you apply the rotation gently or slowly, the amount of disturbance in the soil mass is less. So for attaining the undisturbed strength, then you have to apply the torque slowly, just slowly, and the number of rotations are going to be more. And if you want to disturb the soil mass, now you apply the torque rapidly, and you can see the number of rotations, then the soil is going to be completely disturbed. Okay, so that's about the wind shear test. So by finding the torque, you are going to determine the Cu value. So now that's about the wind shear test. It's a small test only. So basically, mostly we do this test in the field rather than in the lab. Now, so now let's come to the next topic. Sensitivity. Sensitivity. So this sensitivity, I am representing the sensitivity yes. So let me represent the sensitivity as yes, like this. I am representing in this fashion. Yes only, but I don't want to make you feel difficult in understanding the S as a shear strength and all those things. That's the reason why. So sensitivity means ratio of unconfined compressive strength of soil from undisturbed to disturbed, or from undisturbed to disturbed, or remolded state. Remolded state, which means, so S is equals to unconfined compressive strength of a soil mass from the undisturbed state to disturbed or remolded state. So this is going to be the sensitivity. And now if you find out the sensitivity, you can know how much sensitive the soil is, because you know that when you remold the soil mass, the strength will decrease. Yes or no? See, the sensitivity is exclusively for clays only. I'm telling you, when I say QU, mind it, this Wayne shear test is suitable for clays. And you know the previous test. What is the previous test? Unconfined compressive test also generally suitable for whom? Clays. So now, the unconfined compressive strength in its undisturbed state to remolded state is nothing but the sensitivity. So generally, always the undisturbed strength is going to be more than the remolded state. Yes or no? And now you tell me, after disturbing, if you lost more strength, can I say the soil is going to be more sensitive? Yes or no? If I lost more strength, then the remolded strength is less. In the denominator, if the value is very less, then the numerator is going to be more. So the ranges of S is range, sensitivity. If the range is going to be 1 to 4, we call it as a normal. We call it as normal, which means the sensitivity is going to be normal, means normal change. And if the range is going to be 4 to 8, if the sensitivity range is going to be 4 to 8, then you can say the soil is going to be sensitive. And 8 to 15, we are going to say it as an extreme sensitive. And now, if it is going to be more than 15, then you are going to call it as a quick soil. See, quick sand is different, quick soil is different. Quick sand is different and quick soil is going to be different. Mind it that. So quick soil is a type of soil. Quicksand is a type of condition. So what is the example for this quick soil, sir? The example for the quick soil is marine marine clay. So the ratio of unconfined compressive strength of a soil from the undisturbed state to remolded state is nothing but sensitivity. The more the value of the sensitivity, the extreme the sensitivity of the soil mass. So generally, sensitivity is greater than 1. But in case of stiff and fissured, what is meant by fissured? Fissured means cracks. Fissured means cracks. Fissured clays, upon remolding, cracks will close and attains more strength. See, in the case of the stiff and fissured clays, what happens is, when you remold, means when you disturb, see the fissured clay means the cracks would be there, okay? Lot of cracks would be there, something like lot of cracks would be there. These are nothing but the cracks. And when you remold, means when you disturb, the cracks will close and attains more strength. So when it attains more strength, now you tell me, everybody please have a look. Now, what is sensitivity? Upon remolding, the strength is going to be more in the case of whom? Stiff and fissured clays. So when the strength is going to be more, then compared to undisturbed, in remolded, strength more, denominator more, numerator is going to be less. So in the case of stiff and fissured clays, the sensitivity is going to be less than 1. So sensitivity is less than 1 in the case of fissured and stiff clays. The reason is, upon remolding, cracks will close and attains more strength. What is the application of Vane test practically? Is to determine the Cu value, Nana, to determine the undrained shear strength of the soil mass, which is nothing but Cu. What is meant by Cu? You know the Cu meaning is, yes, what is meant by Cu? Undrained shear strength. So the practical purpose of Vane is to determine the undrained shear strength. Yes. So now, from the previous concepts, I can say this Cu, see, from UCS test, this Qu is directly proportional to Cu. This Qu is directly proportional to Cu. Somebody is asking, sir, so how sensitivity is only for clays? Because the undisturbed strength is going to be directly proportional to Cu. Yes or no? And from Vane shear test, you know that T directly proportional to Cu. So I can say the same sensitivity ratio as, which is going to be Qu of undisturbed by Qu of remolded is equals to Cu of undisturbed. Whatever the cohesion of the soil mass in the undisturbed state to cohesion of the soil mass in disturbed state. In the case of clays. So, and I can write the same thing as a torque. What is meant by torque? T is nothing but the torque, Nana. Whatever this is going to be torque, you please look over the torque. Torque means twisting movement. Whatever the moment you apply to twist, that is nothing but the torque. So T of undisturbed, whatever the torque you applied for the undisturbed to torque you applied for the disturbed. See, I can write the sensitivity equation in terms of unconfined compressive strength, and I can write the sensitivity equation in the case of the undisturbed, means whatever this cohesion undrained shear strength Means this is compressive strength, this is a shear strength, and I can write the same sensitivity in terms of the torque also. But mind it, it's a ratio of undisturbed to remolded. So I hope you understood. Sir, how come we measure the torque, sir? It depends upon when the soil is going to be failed. See, total in shear is, if total weight in shear means both top and bottom face is in shear, which means the total top face and bottom face is in a shear. Look, actually, okay, fine. Whatever the soil mass is there, right? Give me a minute once. I have downloaded that picture, but it's not looking for me. How to know soil gets failed? So soil will fail, sir. What is the doubt, sir? Amount of torque applied depends upon the strength. This shearing is going to be happens or not? You please look over this point here. So those who wants to ask me, they're asking. So there is nothing but shearing occurs. So whenever the shear failure occurs, note down the torque required to create the shearing failure. So vein is pushed into the shear and applies torque, and shearing is going to be occurs. And whenever the soil undergoes shear failure, note down the torque at which soil has undergone shear failure, and that torque is directly depends upon the strength of the soil. So the more the strength, the more the torque you are going to be applied. We did not get assignments from chapter 11 onwards, as you told yesterday. Actually, okay, fine. That's about the practicality of sensitivity is to determine how much the soil is going to be loses its strength when you remold it. That's it. So, how can we know, sir, it has failed or not practically? अरे आपको दिमाग है? When the soil is going to be failed, you can see the cracks are not. ये क्या रे भाई? इतना क्वेश्चन से. Okay, now let's see. Okay, let's come to one next topic. Skempton's pore pressure parameters A and B. Sir, what is this sentence of pore pressure parameters, sir? Sometimes if the pore water pressure is cannot be measured practically, then you have to measure it theoretically. For example, let's go back. You see, this is a triaxial shear test. You see, this is a triaxial shear test where we are going to find out the pore water pressure practically by using the piezometer. For example, let's imagine, for example, you are doing the test. Let's say you're doing a CU test, which means partial dissipation of the pore water pressure, which means, so in the case of the CU test, so the remaining pore pressure is measured by the piezometer. Okay. What if the piezometer stops working in between? What if the piezometer stops working in between? Or what if you are not able to measure the pore water pressure practically? Then you have to go for some more approach known as a theoretical approach. That's what mentioned by the Skemptons. So the Skempton says that, Are Baba, when you're doing the test, if somehow, if the piezometer is not working, or if you cannot measure the pore water pressure practically, then I am going to give you a theoretical procedure by using some coefficients, and that coefficients is nothing but the Skempton pore pressure parameters. The coefficients are going to be A and B. So when pore pressure cannot be measured practically, Skempton provided a theoretical procedure to determine pore water pressure using parameters A and B. So when the pore water pressure cannot be measured practically, we are going to use this Skempton's pore pressure parameters. Now let's see. For example, if this is a soil mass that I am going to do a test in the laboratory, which means this is the soil mass. And now, let's go back to the triaxial test. Yes, this is a triaxial test. How many stages are there in a triaxial test? Consolidation stage is there and shearing stage is there. Yes or no? In consolidation stage, we are going to apply a self pressure. Everybody are clear of it. In the consolidation stage, we applied a self pressure. And we are going to apply it in an increasing manner or not? No. And in the case of the shearing stage, we know the deviatoric stress. We apply the deviatoric stress. So in consolidation stage, due to sigma c, some pore pressure will develop. And due to sigma d, some more pore pressure will develop. So totally in the triaxial test, there are two stages. In both the stages, there is a pore water pressure develop. Now I need to find out what is that pore water pressure by using the coefficients. Now let's see. In stage 1, we are applying a confining pressure in all the directions. So now stage 1, consolidation stage. Okay, everybody, can you please tell me, in the case of the consolidation stage, now please tell me this value. What is the external pressure I am applying? Delta sigma C. Okay, what is the external pressure I am applying? Delta sigma C. And now coming to the soil mass, if the soil is going to be fully saturated, if the soil is going to be fully saturated, then the entire external pressure will be equals to delta sigma C. Accept or not? For example, if I apply 50 kilopascals of confining pressure, and if I am fully saturated, then the entire load will be taken by whom? Water. Then what is the water pressure? Then whatever the increase in the pore water pressure, whatever the increase in the pore water pressure in the confining space depends upon the pore water confining stress. Yes or no? So now you please observe the relation between these two is going to be is equals to B into delta sigma C. Delta UC. What is meant by delta UC? Excess pore water pressure developed in the consolidation stage is equals to B into delta sigma C. Sir, what is this B represents, sir? For example, for fully saturated soils, B is equals to 1. Then delta UC is equals to B Yes, sorry. Oh, suddenly internet gone. Let's get back to the same conditions now. Coming to the consolidation stage. So in the case of the consolidation stage, when you apply a pressure of delta sigma c, then definitely in the soil mass, some excess pore water pressure is going to be developed. The delta UC is nothing but B into delta sigma C. In the case of fully saturated soil, then the total excess pore water pressure developed is nothing but the stress that we have been applied. And similarly, for dry soil, B is equals to 0 and delta UC is equals to 0. B is equals to 0 and delta UC is equals to 0. So I hope now you people are clearly audible and I'm clearly visible to you. Yes. So now, first one, yes, delta UC. See, what is this stage? This stage is nothing but the consolidation stage. Sir, you said for fully saturated, I can understand. For dry soil, I understand. This B parameter depends on degree of saturation. Degree of saturation. What is meant by SR? Degree of saturation. And Kempton has provided a relation between the degree of saturation SR and B value as this is the relation, the graph given by the Kemptons. And what is this graph is when the degree of saturation is 0, B value is also going to be 0. When the degree of saturation is 100%, then the B value corresponding to this one is going to be 1. So you see the meaning over here is when the degree of saturation, I can ask that some people may ask again, what is SR, sir? So SR means degree of saturation. So whatever the soil mass, whatever the pressure, pore water pressure developed in the soil mass depends upon the degree of saturation. If the soil is fully saturated, then the pressure that you applied will become the excess pore water pressure. And if the soil is dry, when the soil is dry, no pore water pressure will be developed. And if the soil is going to be partially saturated, then you have to use this graph given by the Kemptons. So this graph is given by the Kemptons, that ratio B and SR, where B depends upon the SR. Based upon the SR, you have to use these values. So probably in examination, they'll give you the values. Don't worry about that. Now, coming to the stage number 2. Coming to the stage number 2. Stage 2. Shearing stage. Stage 2, shearing stage. Sir, in the case of the stage 2, you know that we are going to apply an additional pressure of delta sigma D. What is meant by delta sigma D? Deviatoric stress. So in stage 1, we applied delta sigma C, and due to delta sigma C, what is the pore water pressure? Delta UC. And now in stage 2, due to this delta sigma D, definitely some more pore water pressure will develop, and that relation between these two will be given by A bar. A bar into delta sigma D. A bar into delta sigma D, where this A bar is equals to A into B. A into B, where A bar is equals to A into B. And now this A bar depends on degree of saturation, Because you see this A bar, what is meant by A bar over here? This A bar depends upon degree of saturation. So degree of saturation means, you know, A bar depends upon B and B depends upon whom? Degree of saturation, and over consolidation ratio. I hope you remember the over consolidation ratio, OCR. See, whatever this A is there or not, this is A is a function of the over consolidation ratio, whereas A bar depends upon degree of saturation and over consolidation ratio. So now this A value, A value, you see, observe over here, A bar can be low as minus 0.5 for heavily consolidated clays, which means high OCR, and as high as 3 for loose sands or normally consolidated clays. Heavily over consolidated, which means a high OCR. You know that in the case of the for NCC, if you remember, OCR is equals to 1. And for OCC, over consolidated clays, you please go back, you will get to know in chapter number 11. I told you over consolidation ratio is going to be greater than 1. And now you see there is a relation here. And that relation goes as a curve like this. So on x-axis over consolidation ratio, on y-axis A value, on x-axis over consolidation ratio, and A value as a over this A value. See, this A is going to be A bar is equals to A into B, right? And this A bar depends upon degree of saturation and B, and A depends upon the over consolidation ratio. So now you tell me the minimum value over here is a minus 0.5. The minimum value over here is going to be minus 0.5. So now you see, as the over consolidation ratio increases, A value is going to be decreases. So that's the reason why for a high OCR, A bar is going to be less, and for low OCR, A bar is going to be more. So now here, for fully saturated and heavily consolidated clays, for fully saturated and heavily consolidated clays. Now, can you please tell me, if it is going to be fully saturated, what is B value? B is equals to 1. B is equals to 1, and A bar is equals to A into B. A bar is equals to, and heavily over consolidated, right? See, sorry, this is A bar, not A. So now you tell me, when heavily consolidated clay, what is the meaning of heavily consolidated? Minus 0.5. Then B is equals to 1. Then A is equals to minus 0.5. See, in the case of fully saturated and heavily over consolidated clays, B is equals to 1 and A is equals to minus 0.5. This is A bar, Nana. What is this? A bar. So A bar can be low as minus 0.5 for heavily consolidated clays. So A bar is equals to minus 0.5 is equals to A into B. If it's a fully saturated, B is equals to 1. And now what I want to say here is, sir, for OCC it is less than 1. No, sir, you please go through the You please go through the previous notes, then you will get. See, this A bar is just a coefficient. A bar is just a coefficient which is the multiplication of A into B. So here it depends upon both degree of saturation and over consolidation ratio. So now finally, whatever the pore water pressure that developed in the both the stages, U bar delta U is nothing but delta UC plus delta UD, which means total excess pore water pressure is nothing but stage 1 excess pore water pressure as a delta UC, stage 2 due to deviatoric stress delta UD, and I can write U bar is equals to what is delta UC? B into delta sigma C plus delta UD A into B into delta sigma D, and U bar is equals to B common down delta sigma C plus A into delta sigma D. So this is the final equation we are going to attain. So this is based upon whom? Skempton pore pressure parameters. Now everybody have a look once again. So when pore pressure cannot be measured practically, we are going to use A and B. In stage 1, which pressure we are applying? Delta sigma C. What is the pore water pressure developed? Delta UC, and it depends upon whom? B. So delta UC is equals to B into delta sigma C, and the B depends upon the degree of saturation, and the B depends upon the degree of saturation. So if the degree of saturation is going to be 100%, B is equals to 1. Don't think A and B are constants. They depends upon degree of saturation and OCR. So they can never be constant. They can never be constants. And one more thing, does B can be negative? What is the minimum value of B? 0. What is the maximum value of B? 1. This is B and this is degree of saturation. So B cannot be negative. But whereas if you see A, for heavily consolidated clays, A can be negative also, right? So now I can write B cannot be R. In other words, B will not be less than 0. A can be less than 0. B will not be less than 0, but A can be less than 0, which is going to be minus 0.5. So two states, two pore water pressures, and finally we are going to get this one. What B, what are A? What are the names? आपको दिमाग है तो वो पैरामीटर से भाई, वो पैरामीटर से, उसका नाम कोई नहीं है, वो पैरामीटर से. So लेकिन जस्ट ये स्केम्पटन पोर प्रेशर पैरामीटर, ये स्केम्पटन पोर प्रेशर पैरामीटर बी, उसका कोई नाम नहीं है. Now Now, let's see, that's about the Skempton pore pressure parameters. Yeah. You please look over this question. See, everybody have a look over this question. This is question number 8, some from the classroom practice questions. From the classroom practice questions. In a triaxial test, a soil sample was consolidated. In a triaxial test, the soil sample was consolidated under a cell pressure of 700 and a back pressure of 350. What is the meaning of a back pressure, sir? So the back pressure is, see, the back pressure means when the water is going to be relieved, you are going to call it as back pressure. Means when the water is going to be relieved, right? When you open the drainage valve, whatever the pressure is known as back pressure. So in a triaxial test, under a cell pressure of 700, thereafter with the drainage not allowed, the cell pressure was increased to 800 kilonewton per meter square, resulting in the increased pore water pressure of 445. resulting in the increased pore water pressure of 445. See, the meaning of this one is that? Yeah. See, first initially I am going to send a cell pressure over here. What is this? Sigma C due to this. And through the drainage valve, whatever the pressure that is going to be coming out is known as a back pressure. Whatever here, see the meaning of back pressure is a pore water pressure. In other words, pore water pressure. So now let's go back to the question. Yes. The back pressure means pore water pressure. Okay. So now you see question once again. In a triaxial test was conducted consolidated under cell pressure 700. Back pressure, initial back pressure was 350, pore water pressure. Thereafter, with the drainage not allowed. With the drainage not allowed means you are not allowing the drainage. The cell pressure was increased to 800, resulting in the increased pore pressure of 445 kilonewton per meter square. So stage 1, consolidation stage. In the case of the consolidation stage, what is the increase in the consolidation pressure? What is initial? 700. What is final? 800. So 800 minus 700, which is going to be 100 kilopascals. And due to this increase, what is the increase in the pore water pressure? Initially how much? 350. Finally 445. 445 minus 350. What is this value, please? So, which is going to be 95 kilopascals. Now, the axial load was then increased to give the deviatoric stress as a 575 kilopascals, while the cell pressure remained at 800 and a pore pressure is going to be increases to 640 kilonewton per meter square. Now you please understand this carefully. Initially, what is the pore water pressure I took? 350. And due to cell pressure, what is the pressure that has increased? 445. Now, in stage 2, in stage 2, I am applying a deviatoric stress directly as how much? 575 kilopascal. And while the cell pressure remained at 800, which means no change in the cell pressure, but now pore pressure is going to be developed to 640. So in the stage 2, by the end of the stage 1, what is the pore water pressure? 445. I hope you people are able to understand this. By the end of the stage 1, what is the pressure? 445. And now at the end of the stage 2, what is the pore water pressure? Is final 640 minus 445. Don't take it as 350 because from 350 to 445 due to increase in the cell pressure, and from 445 to the 640, this is due to deviatoric stress. Now can you please tell me the values? So 640 minus 445, which is going to be 195 kilopascals. They are asking the pore pressure coefficients B and E. You know that delta UC is nothing but B into delta sigma C. From this, B is equals to, what is delta UC? 95 by 100. What is this value? 0.95. What is the meaning of 0.95? It's not fully saturated. Now, what is the A value? Now you know whatever the pressure in the stage 2, delta UD is nothing but A into B into delta sigma D. So now what is A? Delta UD by B into delta sigma D. What is delta UD? 195 by B value 0.95 into delta sigma D 575. 195 by 0.95 into 575. The value is going to be a value as a 0.356. You can take it as, if I ask you, we did round it to 2 decimals, the a value is going to be 0.36. I just simply making sure in stage 1, what is the pressure I applied? In stage 2, what is the pressure I applied? Then in stage 1, what is the excess pore water pressure? In stage 2, what is the excess pore water pressure? I hope you understood this clearly. So this is the one question based upon the Skempton pore pressure parameters. Have a look once. Sir, they have given the axial load was then increased to give a deviatric stress. They mentioned now to give a deviatric stress. What is mean by deviatric stress? Additional stress, right? How much additional stress you are applying? 575. They mentioned directly axial stress is going to be increased to give an axial stress, deviatric stress of 575 kilopascals. Now, I hope you have done this homework. Have you? I hope you have done this as a homework. So let me know. Have you done it or not? Sir, at what time FE starts most awaited, sir? Wait for that, sir. Wait for that. Somebody is saying no. Why no, sir? Which means you have not opened the notes. So if you have done it, if you have not done it, you did not open the notes. If you have done it, then you have revised the notes. And you have your material with you. You can look over the answers, solutions for that question. What if drainage was allowed, sir? Sir, if drainage was allowed, then pore water pressure will be dissipated, sir. Then you don't need to find out the pore water pressure. See, when the pore pressure will be there in the soil mass, if you don't allow the drainage, then pore water pressure would be there. If you allow the drainage fully, then excess pressure will be dissipated, right? Sir, any range is Kempton pore pressure parameter. Parimal Bole, I have given you the ranges already. You please go to the notes. See what is the range over here. I told you A bar can be less than, low as -0.5 and can be as high as 3 also. And whereas B, what is the range of B? B is going to be ranges from 0 to 1. I will write this one. A can be less than or equals to or more than 0. Okay, now I hope you have solved this question. So let me give a quick if you have not solved this one, just please look over. So now they have asked analytically. So first, total stress you find out. Total stress analysis. In the case of the total stress analysis, what is sigma 3? Sigma C 200, sigma 1, sigma C plus sigma D, which is going to be 200 plus 150, which is going to be 350. Then phi is 350 minus 200 by 350 plus 200. So sin inverse of 150 by 550. So the value is going to be somewhere like this is phi u 15.83 degrees, and effective stress analysis. In the case of effective stress analysis, sigma 3 dash is nothing but sigma 3 minus u 200 minus 75, which is going to be 125. sigma 1 dash 350 minus 75, which is going to be 275. So phi dash is sine inverse of 275 minus 125 by 275 plus 125. So can you please tell me this value? 275 sine inverse of 275 minus, yes, so 150 by 275, 400. So which is going to be 22.02 degrees. So if you have done it, fine. If you have not done it, then how many days are there to complete syllabus? So probably we will be completing the syllabus within the next week. Today is 27. Probably we will be completing the syllabus within a week. Okay, fine. If you completed, then let's go for the remaining questions. If there is another question. Now, yes. So today I am going to give you homework for this question. See, this is the homework for you. You please solve. Just now I have given you the same way procedure for you. Now here also you see, find the pore pressure coefficient. So this is question number 7, classroom practice question this is. So you please solve this one. Today's homework for you is this one. Just now we have defined that A and B. Now let's come to the last question in the case of the classroom practice questions. So now you see this question is very good question. Yeah, I'll be giving you. Yes. So now this is a classroom practice question. Question number 9. Now, an embankment of 5 meter high is made up of a soil whose shear strength parameters are C dash and phi dash. You see, let's say this is an embankment of, what is its height? It is going to be 5 meters. And what are the shear strength parameters I have given? C dash 50 kilopascals, phi dash 16 degrees. I hope everybody knows. What is the meaning of C dash and phi dash? Drained. Drained means you are going to use effective stress or total stress. Effective stress. The pore pressure parameters they have given as A 0.4, B is going to be 0.92. See, what is the meaning of 0.92? Please look over here. What is the meaning of 0.92? Less than 1, which means soil is partially saturated. I want to say directly, as B value is going to be less than 1, degree of saturation is going to be less than 100%. Yes or no? Because you know that when degree of saturation is 100, then B is equals to 1. And find the shear strength of the soil at the base of the embankment just after the soil has been raised from 5 to 8 meters. Now you are going to raise the embankment to 8 meters. And what is the extra you are going to raise? This is going to be 3 meters. So this is an embankment. And what I want is, I want to find out the shear strength at the base. At the base, what is the shear strength? Assume that dissipation of pore pressure during the stage of construction is negligible, which means there is no dissipation of pore water pressure. Keep that in your mind. No dissipation means excess pressure would be there or not? Yes. And that lateral pressure at any point is half of the vertical pressure. So what is the meaning of lateral pressure at any point, sir? So you see, this is going to be the vertical pressure and this is going to be the lateral pressure. Lateral pressure as sigma H, as we were discussing, this is sigma 1 and here is going to be sigma 3. So what they mentioned is lateral pressure at any point is half of the vertical pressure. Lateral pressure at any point is half of the vertical pressure. So now keep that in your mind. This is the data. Now I am going to find out what is the shear strength at the base. At base of embankment, shear strength S is equals to C dash plus sigma dash into tan phi dash. So I want this. My dear students, already we have C dash. What is C dash? 50 phi dash. Now it's all about whom? Effective stress. And you know that effective stress is nothing but total stress minus pore water pressure. And what is the total stress? What is the total stress? See, they have mentioned the gamma, right? What is gamma? 16.2. Now, what is the total? How much meters you are going to give? 8 meters. Total stress means gamma into 8. Gamma into 8. What is at the end of the construction? 8 meters are there, which means 16.2 into 8. What is this value, please? 129.6. So now U is equals to U naught plus U bar. See, as the soil is partially saturated, U naught is equals to 0. U naught is equals to 0. You can ask me, as the soil is going to be partially saturated. Are Baba, you remember the chapter number 7 concepts? You tell me, what is U naught? Hydrostatic pressure. And you know that pore water pressure will be there if and only if there is a water table. Yes or no? Yes or no? For a partially saturated soil, the initial pore water pressure is going to be 0. And now due to this external load, then there is some excess pore water pressure is going to be developed. So now U is equals to U bar. And you know that what is U bar? So they have given A value and they have given B value. You know that delta UC plus delta UD is equals to V into delta sigma C plus A into delta sigma D. So observe, I want shear strength. Already I have C dash, already I have phi dash. Now I want sigma dash. Sigma dash, I know sigma and I want pore water pressure. So now for finding the pore water pressure, I have A and I have B. So now let me take this element. At the base, this is the element. Whatever this change in the vertical stress, this is going to be delta sigma 1. It is going to be delta sigma 3. The delta sigma 1 is increase in stress due to rise of embankment. Due to rise of embankment. So initially the embankment was only 5 meters. Now due to rise of the embankment, there is going to be excess of 3 gamma or not. This is going to be a surcharge of 3 gamma. So now delta sigma 1 is equals to delta sigma 1 is equals to, I'll write down clearly. Delta sigma 1. So at this point, now you keep your palm. Due to this 3 meters, then definitely you can feel the surcharge as a 3 gamma. What is 3 gamma? 3 into 16.2, which is going to be 16 is 48.6 kilopascals. 48.6 kilopascals. Yes. And you know that the lateral pressure at any point is half of the vertical pressure. lateral pressure at any point is half of the vertical pressure. What is this delta sigma 3? Lateral pressure is equals to half of the vertical pressure, which means 48.6 by 2, which is going to be 24.3 kilopascals. And now we got to know delta sigma 1 as 48.6 kilopascals. So due to rise of embankment, then delta sigma 3 as 24.3 kilopascals. You know that sigma 1 is nothing but sigma 3 plus sigma d. Delta sigma 1 is equals to delta sigma 3 plus delta sigma d. Then what is delta sigma d? Delta sigma 1 minus delta sigma 3, 48.6 minus 24.3. So this is also going to be 24.3 kilopascals. Now you find out U bar is equals to B into delta sigma C plus A into delta sigma D. So what is U bar? Given B value how much? 0.92 into delta sigma C how much? 24.3 plus A. What is the A value I have given? 0.4 into delta sigma D. This is going to be 24.3. So please tell me the value. 1.4 into 24.3 into 0.92, which is going to be 31.298 kilopascals. So once you know the U bar, then what is the shear strength? C dash plus sigma dash into tan phi dash. C dash plus sigma minus U bar into tan phi dash. So what is C value given? 50 plus what is the total stress we got? 129.6 minus 31.298 into tan. What is the phi dash? Phi dash is going to be 16 degrees. So then what is the shear strength, please? Tell me the values. Plus 50. 78.187 kilopascals. So please have a look over once again. I'm going to show you the previous slide. See, you please understand the question. The question is not going to be very good question, my dear student. One of the student asked, sir, if the soil is partially saturated, how come the excess pressure develops, sir? Sir, due to this rise, sir, due to this 3 meters, sir. Sir, now just I'll take you a small example. You take a small wet sample. You take a small wet sample. Wet sample is partially saturated. Okay. Now you take that sample. You apply some load. When you apply some load on wet sample, don't you think the water will come out or not? Why? Due to the excess pressure developed in the water. See, the soil is fully saturated, then there is a hydrostatic pressure. If the soil is partially saturated, then there is no hydrostatic pressure. So U naught is going to be 0. Initially, I told that U naught is going to be 0. So U is equals to U bar. Have a look over this. Sir, when will you upload to 1 to 12 classroom recordings? My dear students, I'm telling you again, the first 12 classes, see, this is, I think today is, I hope so, 28th lecture. I think so, 28th lecture, which means 28 days. So they have kept the first 12 days, 12 means the recording videos for the almost 20 days. They are removing now. They have already provided the dates, which are more than they have already mentioned. So the value is going to be like, just first simply I find out the total stress. I find out the total stress. See, the entire solution depends upon the excess pore pressure development only. This is the excess pore water pressure. I want to find out. I know the B and I know A. I want to find out delta sigma C and delta sigma D. So from the given point, the lateral pressure at any point is half of the vertical stress. So I took the element at the base. This is the base, and whatever the total vertical stress increase and change in the lateral stress. So this delta sigma 1 is going to be increasing due to rise of the embankment. How many meters you rise? 3 meters. So then what is that value? 3 gamma. So 3 into 16.2. So due to rise of embankment, the vertical stress increases by 48.6. Then what is the lateral pressure, which is going to be given as half of the vertical stress, 24.3. Then what is the deviated stress, sir? 24.3. Substitute in the equation, find out the U bar, and you can get down the shear stress. So that's all with these questions. Yeah. Mr. Kaushik, I told you already why the U naught is going to be 0, because the soil is partially saturated. As the soil is partially saturated, moreover, that they did not mention the initial pore water pressure also. Where is yesterday's class? Yesterday's class is in my room. Come. Sir, you said that you will make the videos to be visible till the end of the subject. Please, sir, at least for 2 days, keep those videos. Sir, A equals to minus 0.5. How we get, sir? We don't get, sir. Skempton have given, sir. Now, the last topic in this chapter is modified failure envelope. Modified failure envelope. So what is this modified failure envelope? Stop your discussions now. Listen. So far and so good. We have drawn the failure envelopes. You please go through the previous classes. I have everything with me. So you see how I have drawn this failure envelope. Generally, the failure envelope. How I have drawn the failure envelope. How I have drawn the failure envelope. The failure envelope is a best fitted line as a tangent to the Mohr circle, right? Now, my question for you is, Arey Baba, every time when you draw the Mohr circle and while you are drawing the failure envelope, it is a tedious process. It is a tedious process, and moreover that you are not going to be drawn as an exact line. You are going to draw as a best fitted line. So generally, failure envelope is drawn as a tangent to the Mohr circle by seeing the fitting points, which may not be appropriate. So, and it will be difficult process. In order to not to go for this difficult process, I'm going to be introduced you one more failure envelope known as Mohr failure envelope. Modified failure envelope, sorry, not Mohr failure envelope. Yes. So what is this modified failure envelope? Generally, failure envelope is drawn as tangent to Mohr circle, and it is a tedious process, which means, for example, you see, whatever this is, if you observe, you are going to draw the Mohr circle, and once you draw the Mohr circle, then only you are going to draw the failure envelope. So this is a failure envelope. But instead of taking these values, you know this sigma 3 and you know this is as a sigma 1. So now what I'm going to do is, instead of drawing the failure envelope, now let's see what is the change we are going to observe. So instead of going for this, what we are going to do here is, you know, in order to draw the Mohr circle, you must require the sigma 3 and sigma 1. So circle 1, circle 2, circle 3, circle 4. So you know the sigma 3 and sigma 1. Yes. But now what I do is, instead of drawing the Mohr circles, I take the maximum shear stress points as, so if you observe, whatever this point, again, let me draw. Whatever, if this is a Mohr circle, this is sigma 3 and here it is going to be sigma 1. Instead of taking the Mohr circle, what I do is, what is the maximum shear stress point over here? This is the maximum shear stress or not? Yes. So whatever the maximum shear stress, now this sigma comma tau maximum is going to be taken as a P comma Q. Is going to be taken as a P comma Q. So now you know whatever this is a, see, have you remembered this? What is this value? This value is going to be represented as a P, and that P is going to be sigma 1 plus sigma 3 by 2. And this value is going to be represented as a Q, and what is this Q value? Sigma 1 minus sigma 3 by 2. So now what I am going to say here is, instead of taking the Mohr circle and instead of drawing the values over here, so we are going to take these values as P and Q. Whatever the maximum shear stress points, we are going to take these values as P comma Q, where P is going to be sigma 1 plus sigma 3 by 2. Q is going to be sigma 1 minus sigma 3 by 2. And these are known as stress paths. What we call? Stress paths. So what is the meaning of the stress path? Let's wait for that point. So now what I do is, for a given Mohr circle, there is sigma 3 and there is a sigma 1. Now what I do is, I'll find out the P comma Q also. P comma Q also. What is P, sir? Sigma 1 plus sigma 3 by 2. What is Q, sir? Sigma 1 minus sigma 3 by 2. Why, sir? This is the maximum shear stress point. You know what is the maximum shear stress? Sigma 1 minus sigma 3 by 2. And what is the normal stress at the maximum shear stress? Which is nothing but P. What is this? This is P and this is going to be Q. And that P is going to be sigma 1 plus sigma 3 by 2. Now, instead of sigma comma tau axis, plot details on PQ axis. Plot details on PQ axis. Sir, what is this PQ axis, sir? Now you see the PQ axis. You see the P and Q axis. See, this is a failure envelope. Now what I have done is, for one circle, I'll take a maximum shear stress points and whatever the normal stress over there as a P and Q. So now instead of drawing the more circle, what I'm going to do is, for this particular P, you know, this is a P and this is a Q. This is going to be the Q. For this particular P, this is going to be the Q. For this particular P, this is going to be the Q. Now, as a P value is going to be increases, Q value is also going to be increases. Yes. Yes or no? Because compared to this one, this center point value is going to be more. Accept or not? This center point value is more, means P increases, Q is going to be increases. Now, draw a best fitted line. Now, if you draw a line by joining these points, now, my dear students, this is known as modified failure envelope. This is known as modified failure envelope. For the failure envelope, what is this intercept? C. What is this slope? Phi. Now, just simply I am changing the axis. Instead of sigma comma tau axis, plot details on PQ axis. And whatever this intercept, now I am going to take this intercept as a D and this value as a psi. And we can call this line as a KF line also. We can call this line as KF line also. Sir, what is the purpose of this KF line, sir? Now you see, sir. Sir, why you draw this modified failure envelope? We want C and phi now. We want whom? Shear strength parameter C and phi. But you are taking D and psi. What is the purpose of this one, sir? I hope you understood. You please look over. This is the transformation I am making from the failure envelope to modified failure envelope. I am changing sigma comma tau to P comma Q. And what is P and Q? Whatever the stress at the maximum shear stresses, known as P and Q. So now, you please look over here. Yes. So this is modified failure envelope, KF line. So now P and Q. What is the equation of the K line? Equation of KF line. So equation of KF line. So you know that whatever the line that makes with some intercept is nothing but y is equals to mx plus c. I hope you understood that. And what is y over here? Q. And what is c over here? D plus what is x over here? P tan psi. Tan psi. Now everybody, what is Q? Sigma 1 minus sigma 3 by 2 is equals to D plus sigma 1 plus sigma 3 by 2 tan phi. Tan phi. Sir, what is the purpose of this one, sir? Now, I will go back. Everybody know this equation right now. Everyone have a look over this equation. Have a look over this equation. See, this was the equation that I made for the plastic equilibrium condition or not? Yes or no? Now you see, what is this equation here, please? What is this equation here? Does this just looks like sigma 1 minus sigma 3 by 2? What is sigma 1 minus sigma 3 by 2? Q. Does this just looks like sigma 1 plus sigma 3 by 2, which is nothing but P? Then can I write Q is equals to P sine phi plus C cos phi? Now, see, I am going to rewrite this equation from the plastic equilibrium equation. From the plastic equilibrium condition. See, from this only the plastic equilibrium condition came. Yes or no? So, from the plastic equilibrium condition, from plastic equilibrium condition, let's take it as 1. There I wrote sigma 1 minus sigma 3 by 2 is equals to C cos phi plus sigma 1 plus sigma 3 by 2 sin phi. This is 2. If you have any doubt, you please go through the plastic equilibrium equation. There I have explained clearly. So if you have any doubt, you please go through the here. Here I have explained it clearly. So now by using this from 1 and 2, now can I write whatever the D is nothing but C cos phi and tan psi is equals to sin phi. So these are the details. Yes. From the modified failure envelope. How to determine the C comma phi? First of all, I made the sigma comma tau axis as a PQ axis. And then I find out these values. What is these values? D and psi. So from these equations, what is D? C cos phi. And now first of all, I use tan psi is equals to sin phi. Once I know tan phi is equals to sin phi, then I can write, okay, tan phi value. I can find out phi value, right? Substitute here, then D is equals to C cos phi. So I hope you understood this. The equation of the KF line, we can call it as a KF line. The modified failure envelope is known as a KF line. So now there was one previous gate question based upon this now. Yes, first of all, you see this, the stress path equation for a triaxial test. Whatever this equation, we can call it as this equation is there, right? This equation is known as a stress path equation. So I'll tell you what is the meaning of a stress path also. Just wait a moment. Now, so application of the deviated stress is this is the stress path they have given the respective values of cohesion. You see this, what is the equation of the KF line? What is the stress path equation? Q is equals to D plus P into tan psi. Yes or no? So now from this data, they have given Q is equals to 10 root 3 plus P into 0.5. Okay. So now you know that D is equals to 10 root 3 is nothing but C cos phi. And tan psi is equals to sin phi is equals to, what is the tan psi and sin phi value over here? 0.5. I hope you understood. So now from the given details, this is the stress path equation. And from this stress path equation, I got to know Q is equals to 10 root 3 plus 0.5 P. And from the 10 root 3 and 0.5 P, so this line sin phi, and what is phi? Sin inverse of 0.5, which is going to be 30 degrees. 30 degrees. And from this now, C cos phi is equals to 10 root 3. C into cos 30 degrees is equals to 10 root 3. So C into cos 30 is nothing but root 3 by 2, 10 root 3. Root 3 gets cancelled. What is C value? 20 kilopascals. So this is the modified failure envelope equation, or known as stress path equation. So from that equation, I can write these values. So please refer to the earlier. I hope you understood this. Just finally, at the end, that's the concept. Okay. Now you please look over this sigma 1 and sigma 3. Look, yes, following this is one of the previous gate question, gate 2017. Now you see, following are the statements. Following are the statements related to the stress path in triaxial testing. See, whatever the results I have provided is triaxial test results only, right? The stress point lies at a point of origin in PQ plot. What is P? Sigma 1 plus sigma 3 by 2. What is Q? Sigma 1 minus sigma 3 by 2. Yes or no? Yes. So now you see, if sigma 1 is equals to sigma 3, if sigma 1 is equals to sigma 3, then P is equals to sigma 1 and Q is equals to 0. Yes or no? Why, sir? If sigma 1 is equals to sigma 3, substitute sigma 3 as sigma 1. 2 sigma 1 by 2. 2 gets cancelled. Then if I draw the plot, then this is a P and here it is going to be Q. And you know that the point will be lies on the positive x-axis because this is going to be, this point is going to be sigma 1 because there is going to be Q as 0 or not? Yes or no? So now you tell me, if sigma 1 is equal to sigma 3, the stress point lies at the origin of PQ plot. Is it? No. The stress point is going to be lies at a positive x-axis. Now you see, if sigma 1 is equal to sigma 3, the stress point lies on the p-axis on PQ plot. Yes. So if sigma 1 is equal to sigma 3, the stress point will lies on the p-axis. This is a p-axis on the PQ plot. Yes, true. And coming to the third one. If sigma 1 is greater than sigma 3, if sigma 1 is greater than sigma 3, sigma 1 is greater than sigma 3, P is greater than 0 and Q is also going to be greater than 0, right? Yes or no? Because you see the equations. From the equations, if sigma 1 is more than sigma 3, P is greater than 0. Sigma 1 is more than sigma 3, Q is also going to be greater than 0. If both are greater than zeros, then if you draw the plane, then this is P and this is Q. Both are going to be greater than 0. So the point will be like somewhere over here. This is going to be P comma Q, which positive coordinate. P greater than 0, positive. Q greater than 0, positive. So if sigma 1 greater than sigma 3, both the stress points of P and Q are positive. So now P is false, Q is true, and R is going to be true. So answer is A. Answer is going to be A. No. So what is mean by stress path? And this stress path is nothing but based upon the Lambis. Based upon the Lambis. See, that was given by the stress path. The simple meaning of stress path is locus of maximum shear stress. Locus of maximum shear stress in soil developed in soil, maximum shear stress developed in soil due to change in the loads acted on soil. The meaning of a stress path is locus of maximum shear stress developed in soil due to change in the loads acting on the soil. That's known as a stress path. Now you see, in the case of see, just let me draw that once again. Yes. This is P. Sorry. Now, let's take, there are different type of Mohr circles like this. Now, what is the meaning of the, what is the meaning of the, okay, fine. While you are drawing the Mohr circles, there is one more circle, there is one more circle, and there is going to be one more circle. So these are the different Mohr circles. Now, what is the locus of the maximum shear stress? See, for this is the maximum shear stress, and for this is the maximum shear stress, and for this is the maximum shear stress. Now you see all these points, 1, 2, 3. These are the maximum shear stresses on those points. So now this is sigma and this is going to be tau. And whatever these points are nothing but P comma Q points, which is nothing but sigma 1 plus sigma 3 by 2 and sigma 1 minus sigma 3 by 2. Locus of maximum shear stresses developed in soil due to change in the loads. So due to the change in the loads means if you increase the pressures, then the stresses are going to be increases. Or I can take sigma 3 as a constant. For better explanation, what I do is, now I am going to change this one to for the better explanation. Yes. Okay. So now I'll draw the Mohr circles in such a way. This is sigma 3 and sigma 1. I'm not going to change the sigma 3. So now for different sigma 1s at the same sigma 3, see, you can observe these are going to be the maximum shear stress points. And the locus of all these points is known as stress path. The locus of all these points is known as stress path from here. So you just draw a best fitted line. You just draw a best fitted line. So now if I redraw those things, now if I redraw those things, so these points are going to be like, so this is 0.1 and this is going to be 0.2, this is going to be 0.3. This is known as a stress path line. That is known as stress path line. So what is meant by stress path? Our path itself is a path means line only. What is meant by stress path? Stress path means locus of the maximum shear stresses developed in the soil due to change in the loads. Sir, why you take sigma 3 constant, sir? You can vary the sigma 3, you can vary sigma 1, whatever it is. For different Mohr circles, you know, different maximum stress points. If you join all those points, then you are going to call it as a stress path line. And generally, stress path is preferred on PQ axis. So based upon the stress path, this year 2020 there was a one question, but I'll be explaining that question at the end because that requires other chapter concept also. So wait for that moment. Now stress path. So what is the stress path? P and Q. So what you required is the P comma Q axis. These points are nothing but the P comma Q points. These are going to be the P comma Q points. And you know what is the meaning of P? Sigma 1 plus sigma 3 by 2. And you know what is the meaning of Q? Sigma 1 minus sigma 3 by 2. Yes. And the last topic in this chapter, it won't take 5 minutes. With this, we'll be completing the chapter fully. Can we say KF as stress path? No, we cannot say it as a stress path. Locus means joining a line, Rababa. Locus means for all this. Now there comes liquefaction. Liquefaction. So for this, I have kept some figures. Is that figure? Okay, so now liquefaction. What is meant by liquefaction, sir? Look, during earthquakes, see if this is a ground level, and let's say there is a water table. During earthquakes, due to seismic oscillations, see what is the meaning of this during earthquakes? What is the meaning of this during these earthquakes? So now if you observe, listen to me, you Waltho fellows. Why KFN is not stress path? Sir, break. If you want to leave the class, you leave. I'm telling you, if you want a break, you leave. I'm not going to be stop you. But I told you this is the last topic. With this, we can complete the. Means even I did not have a breakfast also. When I am also hungry. But if we complete this, then we can complete the soil mechanics topic completely from top to bottom. Means without keeping any point aside. So now, coming to the liquefaction. In the case of the liquefaction, during earthquakes, due to seismic oscillations, you know that the seismic oscillations are going to be there. Compressions and rarefactions would be there or not. So due to that, what happens is now, due to the seismic oscillations on the sites, there is an earthquake, due to earthquake, and during that earthquake, due to the seismic oscillations, you take at any point, at this point, that entire pressure will be taken by water or not? Initially or immediately, positive pore water pressure increases. Immediately, positive pore water pressure increases. See, during earthquakes, due to seismic oscillations, what happens is that the particles will undergo some compression, and you know that in the case of the sands and the silts, in the case of the fine sands, I'm telling you again, it's a loose sand. So in the case of the sands and silts, let me go for that point. So I have explained you the shear characteristics, right? Yeah, please look over here. If a loose sand gets sheared, particles will slide over each other. Configuration changes from 1 to 2, compression occurs, and soil behaves like dense, results in positive pore water pressure. So results in positive pore water pressure. Now, if it is going to be a fine sand or silt, in the case of the fine sands or silt, due to seismic oscillations, it will undergo shearing, results in positive pore water pressure. And you know that at any point, effective stress is nothing but total stress minus pore water pressure. If the pore water pressure is going to be increases, then effective stress is going to be decreases. Results in effective stress decreases and becomes effective stress is equals to 0. So the point is, during earthquake, due to seismic oscillations, immediately positive pore water pressure increases because that seismic oscillations will be taken by the pore water, so that at some point the effective stress becomes 0. And yet this condition, which means effective stress 0, cohesionless soil loses its all strength, lost its strength and behaves like a liquid. See, whenever the effective stress becomes 0, if it is a cohesionless soil, you know that S is nothing but C dash plus sigma dash into tan phi dash. If cohesionless soil C dash 0 and effective stress is going to be 0, then the shear strength is going to be 0. At this condition, cohesionless soil loses its strength and behaves like a liquid. Such a phenomena is known as liquefaction. Sir, you said the same point in chapter number 8, quicksand condition. I hope you remember the quicksand condition. So what is meant by quicksand condition? Quicksand condition is cohesionless soil loses its salt strength and behaves like a liquid. That is a quicksand condition. In the case of quicksand condition also, effective stress is going to be 0. So in quicksand condition, effective stress 0, and again soil is going to be cohesionless soil. Again soil behaves like a liquid. Then what is the difference between liquefaction and a quicksand condition, sir? Sir, liquefaction is due to oscillations, seismic oscillations, whereas quicksand condition is due to upward seepage. Keep that in your mind. Are Baba, is there any seepage over here? No. This is just due to earthquakes. And in the case of the quicksand condition, that quicksand condition is due to whom? Upward seepage. Their effective stress is 0 when the upward seepage pressure is equals to submerged pressure. Here, effective stress is 0 when the positive pore water pressure increases, results in effective stress decreases, and finally becomes effective stress is going to be 0. So the note point over here is, in both the quicksand condition and liquefaction, soil behaves like a liquid. That for sure. But liquefaction is due to seismic oscillations or earthquake, whereas quicksand is due to upward seepage. Quicksand condition occurs due to upward seepage, whereas liquefaction is due to earthquakes. Earthquakes means seismic oscillations. Liquefaction is due to earthquakes, which means seismic oscillations. See, I'll show you some figures due to this seismic oscillations. What happens? You see, See, everybody, I'm showing you some figures over here. You please observe, understand over here. Due to liquefaction, what happens is soil will lose its strength or not. I hope you observe during the earthquakes, we used to see the whole structures are going to be fall down. Yes or no? Whole structures are going to be fall down. The tectonic plates means below the ground level, the plates are going to be compressed and they lose its strength. And when the soil is going to be lost its strength, then whatever the structure constructed above is going to be failed. You please look over, see, this is one condition where during the earthquake, the whole building has been leaned. You can observe, this is an apartment, the whole apartment has been leaned over here, and this is due to liquefaction. And you can see this is also here. You can observe the ground surface. You see the ground level is going to be breaks, and you can see the floor is going to be gets breaks or not. So this is due to liquefaction. What is liquefaction? When the soil loses its strength due to earthquakes. Mind it, these conditions are due to earthquakes. There is no upward seepage over here. So with this, we have completed the liquefaction topic. See, these are the figures that I want to show you for the liquefaction. That's it for the liquefaction. No, it won't happen in the case of clays, Nana. It will be happen in the case of only fine sands. That's the reason why I told you cohesionless soil. If it is a clay, then there must be some strength. So it won't be happen in the case of the clay soil masses. It will be happen only in the case of cohesionless soils. Okay. So now it's 11:23. With this, we have completed the chapter number 13, shear strength, and we have completely completed the soil mechanics. And this quicksand condition, you know, this condition is nothing but the boiling condition or a quick condition. I hope you understood the chapter very clearly. So you please go through the class notes and you please solve the gate problems. I have solved previous gate questions and I have solved a lot of previous IES questions also. So you please keep that in your mind and solve those. So with this, I'm stopping the conditions. And with this, we complete the chapter number 13. So end of the soil mechanics. After the break, so now it's 11:24. Have a break of 15 minutes. We'll start the foundation engineering at 11:40. Have a break. back. Sorry for late because I was eating. Let's start a fresh chapter. Come to the next chapter, chapter number 14. So, now in the chapter number 14, 14th chapter, earth pressure theories. Earth pressure theories. Look, now from here onwards, we are going to discuss about the foundation engineering. And for the gate point of view, see, in the foundation engineering, the major 4 chapters are earth pressure theories, stability of slopes, and foundations, as a shallow foundation, bearing capacity, and a deep foundation. So these are the 4 chapters, main chapters. And after that, soil exploration would be there, and sheet pile walls. So 6 chapters are remaining for the gate. And in that 6 chapters, soil exploration and sheet pile walls will be taking so not more than 2 hours, means a half a day session. And the remaining 4 chapters, these chapters will be taking time. And after that, sheet pile walls for exclusively ESC students, there are some other chapters, foundations on expansive soils and geomembranes. That chapters will be discussed only for the ESC people, that will be see at the end. But for the GATE students, next the main 4 topics are in foundation engineering is earth pressure theories, stability analysis of slopes or slope stability analysis, and foundations as bearing capacity and pile foundation. So now let's come to the earth pressure theories. So what is mean by earth pressure? First of all, when you are going to construct an embankment or an earth dam, when you are going to construct an embankment or an earth dam, let's see, for example, yes, I hope you people can able to see this. So there is an embankment or an earth dam. So just now here I am providing you, this is nothing but an this is going to be, there is a slope that you are going to provide for the embankment, yes or no? And if you observe, whatever this is nothing but the slope, whatever this is nothing but an embankment, right? So this is known as an embankment, and for this embankment there is a slope. As a soil mass cannot stand vertically, mind it, soil mass cannot stand vertically, and soil mass is going to be stand with some slope. That slope is known as a natural slope, and that slope is known as angle of repose. Angle of repose. So now let's see. Look, for any soil mass, this is a natural heap. This is a soil heap. And for this soil heap, definitely there is some slope, right? So whatever this slope, let me take this slope as a theta, and that theta is known as angle of repose. Angle of repose. And what is this angle of repose, sir? Natural angle made by soil with respect to horizontal. Natural angle made by soil with respect to horizontal. In the case of sands, this theta is nothing but phi. What is meant by phi? Angle of internal friction. So the point I want to mention over here is, you see, soil mass cannot stand vertically. I hope you have seen while during the construction phase, if you have observed any structure next to that site, there must be a heap of the soil mass. And do you think that heap of the soil mass has a vertical or having some slope? It has some slope. That slope is nothing but angle of repose. So now the point is, in general, soil mass cannot stand vertical until or unless it is a clay. Why clay, sir? Due to cohesion. You can do a vertical cut in the case of clay. I'm going to show the proof in this chapter. So in the case of the clay, you can go for vertical, but in other soils, you cannot go for the vertical. So now let's have an embankment. So whatever the embankment I have represented, now let's take. Let's see, this is an embankment. Yes or no? And this embankment must be having a slope, right? There is nothing but an embankment. It must be having a slope. So now my question is, when there is a slope, definitely as an engineer, we are an engineers, right? As an engineer, are we going to design for a safe slope or critical slope? Safe slope or critical slope? Safe slope. We always design for the safe slope. So now let's take half of the portion, which means, observe. Yes. So let's take a half of the portion over here as now. This is a half of the portion I am showing you, and this is nothing but the soil mass. And generally we design it as a safe slope. Generally we design it as safe slope. Okay, fine. So whatever, this is nothing but a safe slope. And let me take this as an embankment, and this is nothing but the soil mass. So now, my dear students, I'm asking you a question. In the case of the confined areas, in confined areas where slope cannot be flat, where slope cannot be flat. In the case of confined areas where the slopes cannot be flat, now I have to raise the slope. When I have to raise the slope, now you see, I will be raising the same slope up to a critical slope. This is a critical slope. Mind it. Everybody have a look. See, if you want to construct this slope, if you want a flat slope, then the base area should be more, accept or not. But in the case of confined areas where you cannot provide that much base, then you have to raise the slope from flat slope to steep slope. And you know, you have designed for safe slope. But what is the maximum rise that you can do? Up to critical slope. Now my question is, if I raise the slope exactly vertical, If I rise the slope exactly vertical. Now, can you please tell me what happens over here? What's happened here? Whatever this soil mass over here, this will be most downward. And then this is a critical slope, right? As it is a critical slope, then this is going to be a failure wedge. What is the meaning of the failure wedge, sir? Sir, once this is a safe slope, fine. If you go for critical, fine. But if you go for a slope more than critical slope, whatever the soil mass will move downwards and the soil will be shear off or not? Yes or no? Yes. So for the embankment, safe slope, this is a critical slope, and beyond the critical slope, whatever the soil, if you rise, then it is going to be failure. And now, sir, if it is a failure, how, sir? In order to support this, there we are going to construct, a wall to support the structure. A wall to support the structure. Give me a minute once. And this wall is known as retaining wall. So whatever the wall yes, whatever the wall we have constructed over here, this is known as retaining wall. So the point is, in confined areas where slope cannot be flat or where no provision of flat slopes, and in order to support soil, a soil, the structure constructed is retaining wall. So what is the meaning of retaining wall? The meaning of retaining wall is retain to support wall. So retaining wall means the wall that constructed to support the soil. In confined areas where there is no provision of flat slopes, in order to support the soil, the structure constructed is retaining wall. Now, my dear students, here, if you observe carefully, if I take a small element over here, if I take an element over here, you see, this is a critical plane or not? Yes or no? This is a failure wedge. So now if I take an element, that element please. Yes. So if I take this element and now that element, take it outside. In the element, whatever the element I took, see this element only on the critical slope, See, this is a critical slope means a failure slope or not? I don't need to say again and again. The meaning of critical slope means failure slope. So beyond that, the soil is going to be most downward, known as a failure wedge. So now if you see on this element, there is a one vertical stress and there is a one lateral stress at some depth z. At some depth z, there is a vertical stress and there is a horizontal stress. Now I am not mentioning as a major principal stress. nor minor principal stress. Keep in your mind, I am discussing about the field now. So far in the case of soil mechanics, we have done the analysis. Now coming to the practical situations. So confined areas means in the case of less area, in the case of small area, where you have to provide the slope exactly vertical. There you need to provide a support known as a retaining wall. Now where sigma V is vertical stress and sigma H is known as lateral earth pressure. Lateral earth pressure. So what is meant by lateral earth pressure, sir? Earth pressure exerted by soil on wall. Whatever the earth pressure exerted by soil on the wall is known as a lateral earth pressure. So keep that in your mind. Now you please observe, see whatever this pressure you observe, this is known as lateral earth pressure. So if I take that element, on that element, whatever the pressure exerted by the soil on the wall is known as lateral earth pressure. I hope you understood this. Now you tell me, do you think sigma V and sigma H both are same? Do you think sigma V and sigma H both are same? So no, never the sigma V and sigma H are going to be same. Sigma H is not equals to sigma V. Why, sir? If you make sure that tau in the previous chapter, sigma 1 minus sigma 3 by 2 sine 2 alpha. Forget about which is major and which is minor. I am not saying, I'm telling you, still I did not say which is major. Sigma V is major or sigma H major, I did not say to you. So, but if sigma V and sigma H are same, then major and minor are same. See, if sigma V is major, sigma H is minor. If a sigma H is major, sigma V is going to be minor. But any one of these two, one should be major, other should be minor. If both are going to be same, then the shear stress is going to be 0. If a shear stress is going to be 0, then there is no shearing at all. Yes or no? There is no shearing at all. So in the case of soils, both are not going to be same. In soils, both are not going to be same. So I can write, in soils, the lateral earth pressure is not is equals to vertical stress. So then what is the relation, sir? Then there is some relation, sigma H is equals to some portion of sigma V. Now this is the relation between the vertical stress and the lateral stress, where K is coefficient of earth pressure, which depends on type of soil and movement of wall. Type of soil and movement of wall. So finally what I want to say over here is, when you provide a slope beyond a critical slope, then the soil starts to slide. Yes or no? If there is no support, then the soil will fall. Now listen to me. This is a wall and this is a soil. If the soil is going to be slide, if there is no wall, then the soil will fall down. But if there is a wall, then this soil mass will get supported by this wall or not. And now this soil mass will exert a pressure in which direction? Lateral direction. Vertical stress, and this is a lateral direction. Whatever the stress exerted by the soil on the wall is known as lateral earth pressure. And based upon the movement of the wall, the K value is going to be changes. So for that, I want to show you some figures. You see, observe clearly in this. I hope if you observe, see everybody, what is this? This is a retaining wall. And now, if you observe here clearly, this soil mass is going to be falling down or not? You see, the soil mass is going to be hitting the wall. When the wall is going to be hitting, then the wall is moving away from the backfill or towards the backfill. Away from the backfill or towards the backfill. You please observe. So this wall is moving from the soil mass. This is known as backfill, or this is known as soil. So this soil mass hits the wall and this wall is moving away. Now you see the biggest failure over here. If you observe, whatever this is nothing but the retaining wall, whatever this is known as retaining wall. Now this entire wall has been failed down or not? Yes or no? So actually there are some failures, and what are those failures? Based upon the moment of wall. This is the moment of the wall, and as the wall is going to be failed down, then the soil is going to be slides. You see, you observe, this soil will exert some pressure over the wall or not? I hope you understood the meaning over here. And now this is a flyover. This is a flyover bridge, and whatever this is nothing but retaining wall. This is also going to be retaining wall, right? Yes. So whatever this is nothing but the flyover bridges, right? So I hope you can see the flyover bridge which will be having a retaining wall, and in between, what is that? Soil. Somebody has asked me, sir, what is the confined area, sir? This is the confined area, sir. Where the soil is going to be about to stand vertical, there if you provide a support, that support is known as retaining wall, and due to the movement of the soil mass, the wall may move away from the backfill or towards the backfill. If you see here, there is no movement at all. Is there any movement of wall here? No. So now I hope you can understand what is the meaning of the retaining wall and what is the pressure exerted by the soil mass over here. So that's all. So this is about the figures. Now let's come to the yes. So now, as you know, this K value, just now I said you, that depends upon the type of wall movement. Now you see, based on wall movement, based on wall movement. Number one, a trust condition. A trust condition. What is the meaning of yet rest? The meaning of yet rest means there is no movement of wall. There is no movement of wall. At rest, no movement at all. So no movement of wall. When there is no movement of wall, no sliding of soil, no sliding or yielding. We can call the sliding as a yielding of soil. Sir, can you tell me one example where you can see this one, sir? Sir, if you see this figure, sir, in this figure, the wall is making as a vertical or not? Yes. So I hope you remember the basement floor walls. I hope you remember the basement floor. See, I am going to show the same picture in a way now. This is it's not working. It's not working. Okay, fine. If you see, this is nothing but a bridge abutment. I'll draw. It doesn't take much time. I have drawn these figures and I kept it aside, but don't know what has happened. Okay, fine. Now let's take this figure into the consideration. No movement of the wall. Arey baba, yield means moving. Yield means moving, sliding. No sliding. So now let's say in this case, no. You observe, see, whatever this is nothing but the basement floor. Whatever this is nothing but the basement floor. So if you see, this is going to be the basement floor, whatever the floor you are going to observe. This is the basement floor, and whatever this is nothing but the basement slab. I hope you know that for every building now, especially the commercial buildings, public buildings, you can see the soil mass, you can see the basement floors. Yes or no? Where does the basement floor locates? The basement floor locates below the ground level or not? Yes or no? As the basement floor locates below the ground level, means this is the ground level, and whatever this is nothing but the soil or not? Yes or no? So in this case, whatever the slabs, in the case of our structure also, for constructing our structure, residential building, we are going to lay a basement slab and then we are going to fill it. And we used to call it as a basement. We used to call it as basement. This is a slab, and whatever this is nothing but the soil mass. And what are these are nothing but abutments or basement slab floors. This is nothing but retaining wall. And whatever the soil mass you take, this soil mass cannot move in any direction. The soil mass cannot move in any direction. This is a yet rest because there is no movement of the soil mass. There is no movement of the soil mass. This is one example. Example as a basement floor. Now the same one I'll take in a different way. Observe this. Yes, you please observe this now. See, whatever this is nothing but highway. You see, this is going to be highway or not? Yes. Whatever this is nothing but the wall. Now I am representing you. This is a highway where your vehicle is going to be passes. Where your vehicle is going to be passes. So this is a highway where the vehicle is going to be passes. And now this is the retaining wall. And whatever this is nothing but the bridge abutments are not. Whatever this is nothing but the bridge abutments. So as it is a bridge abutment, now this is a highway pavement. Whatever beneath this, that is a soil mass. And as this soil mass is going to be confined between two walls, as the soil mass is confined between two walls, there is no movement of wall, no movement of soil. That is the reason why we call it as at rest condition. What is meant by at rest condition? The at rest condition is the condition at which there is no movement of the soil mass. So example, basement slab and bridge abutment. Basement slab and bridge abutment. So now, if you see, in the case of the basement slab, so now as there is no movement of the soil mass, then I can say strain in lateral direction is 0. So which means the strain in the lateral direction is going to be 0. So what is the meaning of a strain in lateral direction 0, sir? Sir, as there is no yielding, when there is no movement, sliding or strain will be there or not? No strain. And you are going to use the elastic theory for the analysis. Elastic equilibrium condition, which means what is the meaning of equilibrium over here is at any point in the soil mass there is no shearing. There is no shearing. So now let me take a small element over here. Let me take a small element. Yes. So this is the element I am taking. Now let's take that element outside. Let's take that element outside. So now this is the element. Yes. So on this element, you see in the vertical direction, this is nothing but vertical stress. And in the lateral direction, this is going to be sigma h, and this is also going to be sigma h. Sir, why you took the lateral direction as sigma h? I told you this topic in the previous chapter. Vertical load is sigma v. In all the other directions, they are nothing but lateral directions. So this is nothing but the lateral direction. As I know, the sigma h is equals to 0. What is the value of EH now? You see, yesterday I explained you sigma h by E. The strain in the lateral direction, and due to sigma 1 lateral strain in the direction, and due to the sigma h again lateral strain, sigma h by E is equals to 0. Yes. So now if you see this figure, whatever the soil element I have taken, in that soil element there is a vertical stress, there is a lateral stress, but there is no movement. As there is no movement, strain in lateral direction is going to be 0. So now I can write this one as sigma h in minus mu into sigma v. And now can I take 1 minus mu common is equals to mu into sigma v. You please observe over here. This is nothing but E. E will be going outside. Then sigma h, take out sigma h common because I want sigma h. Now finally, sigma h is nothing but mu by 1 minus mu into sigma v. Sigma h is equals to mu by 1 minus mu into sigma v. Let's go to the earlier. What is the relation between sigma h and sigma v? Sigma h is equals to k into sigma v. So now, my dear students, this, what is the k value over here? The k value is going to be mu by 1 minus mu into sigma v. And as I am discussing about the at rest condition, so now I am going to write this one as a P naught is equals to K naught into sigma V, where P naught is known as at rest earth pressure. At rest earth pressure. P naught is going to be K naught into sigma V, where K naught is going to be at rest pressure coefficient, and K naught is equals to mu by 1 minus mu. It can be write as in terms of phi 1 minus sine phi. It can be write as this is an empirical value. It can be write as 1 minus sine phi. So don't worry about these values over here. Okay. So finally the K value is going to be mu by 1 minus mu, which is going to be 1 minus sine phi. Yes. This is at rest condition, and the examples I have given you is a basement slab or a bridge abutment. So this is nothing but basement slab, and in this zone the soil mass is in an at rest condition as there is no movement of the soil mass. I hope you understood the at rest condition. So what is the sigma h over here? At rest at the pressure P naught. Give me a minute, I'll take some water. Okay. So we have been discussed about this at rest condition. Now coming to the active state. Second one, active state. At rest condition. Now second one is going to be active state. So what is this active state, sir? When wall moves away from backfill. When the wall is moving away from the backfill, then you are going to call it as a active state. So what happens over here? Let's draw the figure again. This time I'll be taking this as a retaining wall. Yes, it can be any name. So I'm taking a vertical retaining wall. So I'll be said as a vertical retaining wall. Now, whatever, this is nothing but the soil. So this is known as backfill. Back of a wall, that what you fill is nothing but the backfill. And you know, in the starting, whatever I shown, this is a critical slope partner. So now you see, I can draw a plane. Whatever, this is nothing but the critical plane. This is a critical plane. Now you see, when the wall is going to be moved away from the backfill, when the wall is going to be moved away from the backfill, which means the wall starts to move away from the backfill, so whatever, this is nothing but the movement of wall. So now, when the wall is going to be moved away from the backfill. I hope you understood what is happening over here. So if this wall is going to be moving outside, whatever, this is nothing but the strain delta H, and whatever, let's take the total height of the wall is going to be H. The total height of the wall is going to be H, and the lateral yield is going to be delta H. So when the wall moves away from the backfill, now you tell me what happens to the soil mass. See, whatever the soil mass, think and say this is a wall, and if the wall is going to be moves away from the backfill, then the soil mass, this entire wedge will move downward or not. Whatever this wedge, this failure wedge will move downward. So now you see, when wall moves away from the backfill, wedge or soil wedge moves downward, and you see a resistance. This is nothing but the shear resistance or not? This is nothing but shear resistance. You observe, whatever the soil mass over here, this soil mass will move downward. This is the movement of the soil, and this is nothing but the shear resistance. Now think about carefully. This is the soil, and if the wall is moving, then slowly at this element you can take whatever the element you can observe on this element. This is sigma V, and this is going to be sigma H. So when the wall moves away from the backfill, soil wedge moves downward, and the lateral stress, the lateral pressure exerted by soil decreases up to maximum shear resistance. So what is the meaning of this one, sir? Up to maximum shear resistance and attains plastic equilibrium. So when wall is going to be moves away from the backfill, soil wedge moves downward, and you see the contact between the wall and the soil will be losses or not. Now you tell me, when the shear resistance is going to be moving upward, when the shear resistance is going to be moving upward, it will not allow the soil mass to move downward. Yes, then slowly the wall is moving away and the soil is here. The pressure exerted by the soil on the wall is going to be less. Yes or no? When the wall is stable, it will exert more pressure. And when the wall is moving away from the backfill, the lateral earth pressure will be decreases and attains a plastic equilibrium. Such a state is known as active state. You please understand this point clearly. The lateral pressure exerted by soil decreases up to maximum shear resistance and attains plastic equilibrium. So now if I take that element outside, so if I take the element outside, now on the critical plane, this is going to be vertical stress, and here it is going to be lateral stress. So now you tell me, when wall moves away from backfill, soil wedge moves downward, the lateral pressure exerts decreases, which means, now can you please tell me, out of these two, which is major and which is minor? It will decrease means now sigma V is going to be major, and as a lateral pressure decreases means sigma H is going to be minor. I hope you understood the meaning. And then the plastic equilibrium attains. The meaning of plastic equilibrium means every point in soil wedge reaches shear failure. Every point in soil wedge reaches a shear failure. That is the meaning of the plastic equilibrium. Elastic means no failure. Plastic means failure. So now you tell me, in this case, which is going to be, see, the entire discussion I am making you is just for the sake of knowing what is major and what is minor. You see, I started the chapter with the vertical and the horizontal. I did not tell you which is major and which is minor. Now I am telling you, here it is going to be major is going to be vertical, minor is going to be horizontal. Why? When the wall is moving, the soil nature is going to be, the pressure exerted by soil on the wall will be decreases, which means lateral pressure decrease, and this is going to be called as active earth pressure, where PA is known as active earth pressure. So now you see what happens over here is, whatever, this is nothing but the critical plane, right? Whatever, this is nothing but the critical plane, no? So this is going to be critical or failure plane. And you know, if it is a major principal stress, then this is going to be alpha F R naught. I hope you understood. So if this is going to be the major principal stress, then this is going to be major principal plane, and this is going to be minor principal plane. Minor principal plane. I hope you remember this condition. If it is a major principal stress and this is minor principal stress, then what is alpha F? Alpha F is going to be 45 plus 5 by 2, which means the angle made by the failure plane with respect to horizontal is going to be 45 plus 5 by 2 in the case of active state. So now, is one of the previous IAS question also. What is the angle made by the failure or critical plane in the case of active state with respect to horizontal? What is that angle? 45 plus 5 by 2. So now, how to determine this PA, sir? PA is equals to KA into sigma V. It is similar to the P naught, but I did not give you how to find out the K naught. Sir, I know PA and I know sigma V. How to find out KA, sir? Just wait. How to determine the KA and how to determine PA? There is one theory known as Rankine's theory. See, what is the chapter name? Earth pressure theories. Just now I am discussing about only earth pressure, and I am going to discuss later how to determine the theories also. So wait up to that moment. Now, PA is equals to KA into sigma V. So I hope you understood here. What is a major? Major is going to be vertical, minor is going to be horizontal. Now, where you see this one is example, all ordinary retaining walls. So please look over. See, can I say this is nothing but the active state? Because the wall is moving away from the backfill, and this is a rest condition. And you see, this is also going to be wall move away from the backfill. Can I say this is also going to be active state? But this failure has happened. Failure has happened. And active state occurs yet low strain. Delta H by H is equals to around 0.2 to 0.5%. The strain is going to be very, very less. The strain required to move is going to be 0.2 to 0.5%. So the movement is going to be very, very small movement, Nana, with a lesser small movement, which is, you see, if this wall is going to be moved a little bit, then the entire soil will slide and the failure is going to happen. Here also, if the wall is going to be moved a little bit, then the entire soil will fail and the failure is going to happen. So now coming to the passive state. In the case of the passive state, when wall moves towards soil. Now here when wall moves away from the soil, soil moves downward, and this expansion, the extension should be there. Some of the people, sir, why the lateral earth pressure is going to be decreases? Just think, Nana, this is a wall, and earlier the soil is going to exert more pressure. If the wall is moves, the gap between the wall and the soil, whatever the soil mass will become loose or not, and this soil will not exert much pressure than the initial. This is initial one, and this is going to be the final one. Now, when the wall moves towards the soil, let's draw the figure again. Again. There is a wall. So this is going to be the backfill. Now you see, this is the critical plane. Critical plane. Now, if you observe, if the wall is going to be moving towards the backfill, then you please try to understand. Now, if the wall is going to be moved towards the backfill, what happens over here is the soil mass will move upward and the shear resistance would be downward. This is soil movement and this is a shear resistance. So now, you please look, when wall moves towards the soil, then soil moves upward and inward, results in compression of soil, and the lateral pressure increases than vertical pressure up to reaching plastic equilibrium. Up to reaching plastic equilibrium. See, the meaning of this one is, Baba, if you're here, if somebody hits you hard, which direction it is hitting? Which direction it is hitting? Lateral direction or not? So now you tell me, if it hits lateral direction, then in the lateral direction, soil will undergo compression or not? Then the lateral pressure is more than the vertical pressure. Then the lateral pressure is going to be more than the vertical pressure. So when the wall is going to be hit the soil mass, now the soil mass will move upward and inwards. Inwards means inside, results in compression of the soil. And the lateral pressure, whatever this lateral pressure, see, when the wall is coming close, then the soil will exert more pressure, right? When wall moves away, soil will exert less pressure. When the wall moves close, the soil will undergo compression and it will exert more pressure. So, if I take the element over here, now this is vertical stress, this is the horizontal stress. Now you tell me, here the lateral pressure increase means now this is going to be major principal stress and here this is going to be the minor principal stress. And you know, this is major principal plane and this is minor principal plane. You know the meaning of alpha F? Yes. What is meant by alpha F, please? Alpha F means angle made by failure plane with respect to major principal plane. Angle made by failure plane here sigma will represents self-weight nana, not external loads, because we are not applying any external loads on the backfill or not. You see here, please. You see, have you applied any external load? No. So here also there is no external load. Don't worry about that. Now you see, whatever this is nothing but the critical plane, right? So let's take the critical plane. This is a critical plane. So now, if you observe the critical plane, so this critical plane, you know that this is a failure you know that this is a failure plane. And what is meant by alpha F? Angle made by the failure plane with respect to major principal plane, which means this is alpha F now. So I hope you people understood what is meant by failure plane. This is a failure plane or a critical plane. Yes. So the angle made by the failure plane with respect to major is alpha F, but I want with respect to horizontal. So if I want with respect to horizontal, now you tell me this is 90 degrees, then what about this value? This is going to be 90 minus alpha F. So what is 90 minus alpha F? 45 plus 90 minus alpha F means 90 minus 45 plus 5 by 2, which is going to be 45 minus 5 by 2. So what is the angle made by the failure plane in the case of the passive state with respect to horizontal? This is with respect to horizontal. You please observe what is this value. This is going to be with respect to horizontal or not. In the case of the active state, this is major principal plane, so I took directly alpha. But in the case of the passive state, the major principal plane is this one and the minor principal plane is going to be the vertical. So in this case, if you observe, in this case, whatever this major, this is going to be the this is known as passive earth pressure. So here also yielding of soil occurs and yet high strain of 2 to 5%. 2 to, this is 0.2 to 0.5%. This is going to be 2 to 5%, which means delta H by H. So, you know, why I'll tell you later. Don't worry. Why I'll tell you. Delta H and he is going to be H. So you might have a doubt. Sir, active state occurs at low strain. Passive state occurs at a high strain. Because in the case of active state, Active state occurs very easily, but passive state does not occur very easily. The passive state does not happen very easily. So whatever PP is going to be Kp into sigma V. And how to determine this Kp? Now we see where Pp is passive at the pressure, Kp passive coefficient, means passive at the pressure coefficient. The passive at the pressure coefficient. So I hope, yeah, the points that you need to remember in the three states is, you see, and where you see this passive states, example, sheet pile wall. Example, sheet pile walls. Actually, I have drawn that figure, but I don't know why it is not coming. This is nothing but a sheet pile wall. So I don't know where it is eliminated also. So whatever, this is nothing but the sheet pile wall. So if this sheet pile wall, okay, fine, I'll draw that again. In the case of the sheet pile wall, yes, you see, this is a ground level, and this is nothing but the backfill, and this is the natural ground level. So this is not the ground level, this is the backfill. Now you see, you observe, in the case of the sheet pile wall, this is known as a sheet pile wall. In the case of the sheet pile wall, due to the soil pressure, what happens is the soil yes. So this pile wall will deviate like this, and whatever this state above over here is nothing but active state, because wall is moving, and you see below here, this is nothing but the passive state. So passive state can be seen only in the case of the sheet pile walls. Above is going to be active state and below is going to be passive state. So, and now let's see how to determine this passive earth pressure and active earth pressure. See, I have given you three pressures: at rest, active, passive. And if you observe, the common thing in the three is going to be sigma V, and sigma V. So vertical stress is same, but the P naught depends upon K naught, PA depends upon KA, and PP depends upon KP. So let's see. The important points that you need to remember in these two is in the active state, which is major, vertical is major and horizontal is minor. So when wall moves, the lateral pressure will decrease. And when the wall moves towards the soil, lateral pressure increases more than the vertical pressure. So here vertical pressure is going to be minor principal stress and horizontal pressure is going to be major principal stress, and that horizontal is nothing but PP, which is nothing but passive earth pressure. So now let's take the theories. Rankine's theory. So with this theory and assumptions, I'll close this session. It's not going to take much time, just 10 more minutes. Please wait. So now, Rankine's theory. For every theory, I'm telling you, for ESC people, every theory, every chapter, every theory, the assumptions are very, very important. Because in the ESC, they will ask you the questions regarding to which of the following statements are correct regarding to Rankine's theory, Terzagh's theory, Coulomb's theory, and whatever the theories that comes. Now, coming to the Rankine's theory. For every theory, there must be some assumptions. Soil is homogeneous, isotropic, semi-infinite. These are the common assumptions. And soil is dry and cohesionless. What is the meaning of cohesionless? Cohesionless means C is equals to 0. C is equals to 0. So now, apart from this, the other assumptions are back of wall is smooth. You see, whatever the walls I have represented, this is a wall, right? Retaining wall, and this is also retaining wall. The back of the wall is going to be smooth, so that there is no friction between wall and soil. Wall friction represented with delta is equals to 0. Back of wall is going to be smooth. And apart from that, backfill surface is planar. So what is the meaning of backfill surface, sir? You see, this is a backfill or not? Whatever, this is nothing but backfill surface. So this is a backfill surface. Whatever the backfill surface is going to be planar, and which means it can be horizontal or inclined. Mind it, in some of the textbooks they mention only horizontal, so that's wrong. That's wrong, because based upon this, there was one previous ESC question also. In the case of Rankine's theory, backfill surface is not horizontal, it is planar. Planar means it can be horizontal, it can be inclined, it can be like this. This is nothing but plane, planar. Passive equilibrium occurs, and you know the meaning of passive equilibrium already. And failure plane is a planar. So these are the assumptions made by the Rankines. Soil is dry and cohesionless, back of wall is smooth, and backfill surface is planar, passive equilibrium condition. So now, based upon this Rankine's theory, now I am going to determine the PA. It won't take much time because you know already, and it's just application of these things. Now you see, from plastic equilibrium condition, so this is the plastic, sorry, it's not passive, plastic equilibrium condition. From plastic equilibrium condition, sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. Sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. As I mentioned, c is equals to 0, then sigma 1 is equals to sigma 3 tan square alpha f. So now, in the case of active state, so let's go back to the active state. In the case of active state, which is major, please? In the case of active state, which is major? Vertical is major, and which is minor? Horizontal is going to be minor. So in the case of the active state, the major is vertical stress, minor is lateral, which is nothing but a PA. So now you please substitute these values over here. So if you substitute, then sigma 1, sigma V is equals to sigma H, or I can directly write it as PA tan square alpha F. And what is PA? 1 by tan square alpha F into sigma V. And this PA is known as KA into sigma V. So now I got to know, you see, what is a PA value? KA into sigma V or not? Now from the Rankine's theory, I got to know the KA. So what is KA, please? Now KA is equals to 1 by tan square alpha F. So if you remember the previous, while I was deriving the plastic equilibrium condition, this tan square alpha F is nothing but KA is equals to 1 minus sine phi by 1 plus sine phi. 1 minus sine phi by 1 plus sine phi. So this is the KA value, because you know that tan square 45 plus phi by 2 is nothing but 1 plus sine phi by 1 minus sine phi, which means 1 by tan square is nothing but 1 minus sine phi by 1 plus sine phi. So that's how I have find out the KA value. Similarly, in the case of passive state, the major is nothing but the horizontal, which is nothing but PP. Minor is going to be vertical. So now from the equation, sigma 1 is equals to sigma 3 tan square alpha F. Sir, why you are taking only tan square alpha F? Because this theory is applicable for whom? C is equals to 0. I'm telling you, we are discussing about cohesion-less soils. Sir, what if there is a cohesion? We'll see it later. Wait for that moment. So sigma 3, then now I can write directly PP is equals to tan square alpha F into what is sigma 3? Sigma V. Then what is PP? KP into sigma V. And now that KP is equals to tan square alpha F, which is going to be 1 plus sine phi by 1 minus sine phi. 1 plus sine phi by 1 minus sine phi. So I can write this Kp as 1 by Ka also, because you know the Ka is nothing but 1 by tan square alpha F, and Kp is going to be tan square alpha. So now let me conclude everything for this. The conclusion are, number 1, in the case of at rest condition, P naught is equals to K naught into sigma V, where the K naught is equals to 1 minus sine phi. Number 2, active. PA is equals to Ka into sigma V, where Ka is equals to 1 minus sine phi by 1 plus sine phi. And third one, passive. In the case of the passive, PP is equals to Kp into sigma V, where Kp is equals to 1 plus sine phi by 1 minus sine phi. 1 plus sine phi by 1 minus sine phi. If we observe clearly, yes, if you observe clearly, the P naught or PA or PP, any earth pressure depends upon its coefficient K naught, Ka and Kp. K naught, Ka and Kp. What is the sign conversions I have done? No. So K naught, Ka and Kp. Now, if you see these values, Which value is more? Come on, you please tell me. Which value is going to be more? This is the final conclusion. Which value is going to be more out of all? Or first of all, you tell me which value is going to be less. Now you observe, please. In the case of the Ka, 1 minus sine phi, which means less than 1 by 1 plus more than 1. Array lesser than 1 by more than 1, which will be much less than 1 or not? Yes or no? Ka value is going to be very least out of all. Ka value is going to be least out of all. Whereas if Ka is going to be least, then Kp should be more or not? Yes or no? If Ka is going to be least, then Kp should be more. If Ka is going to be least, Kp is going to be more. Then what about K naughts are in between? Ka is less than K naught, less than Kp. So out of all the coefficients, active coefficient is going to be less than at rest, than passive. So Pa, active at the pressure, is less than P naught and less than Pp. So I hope you understood the meaning over here. So now, based upon this, what I am going to do is, so I'll take the moment of the wall moment. Wall moves towards and wall moves away from backfill and no movement. You please look, I am representing the pressures of sigma h on the y-axis and the movement of the wall on the x-axis. So now if you observe, if the wall is going to be moving towards, then this is going to be a passive state or not? Passive. And wall moves away, this is going to be active. Now if I represent the values, you see on this axis, when wall moves away, active, the active value is going to be less. The active value is going to be less. So this value, this is active at the pressure. But compared to no movement means at rest or not, then this value is going to be P naught. And when wall moves away from the, towards the backfill, then the PP is going to be more. So whatever this value is going to be PP. Now if you join the graph, this is going to be the graph that you can get to know. Now, my dear students, you please tell me which condition requires more lateral pressure. Which condition requires more lateral pressure? Passive state or active state? Passive state. Passive state requires more pressure, which means passive state, whatever the strain required to create passive state is more than compared to the active state. So strain required to create passive state is more than active state. Why, sir? You see, sir, this one, you please observe from this, which pressure is more? Passive pressure is more. Arey Baba, when the passive pressure is going to be more, in order to create this strain delta H by H, it should be more. Because if the wall moves more, then only the pressure is going to be more. Now, in the case of the active state, so the pressure required is less. So if the wall moves very little bit, if the strain is going to be less, also active state creates. But in passive state, it requires more strain. So now you tell me, which one is the common failure that we see is an active state? The common soil failure is active state, because in the case of active state, the strain required to create active state is very less, which means If wall moves by just 0.2% to 0.5%, the failure is going to be active failure. That is the reason why most of the failures are active failures. This is active failure, and this is also going to be active failure. If the wall moves a little bit, then that strain is low strain will create the active state. But in order to create the passive failure, it has to move a lot. So these are the things that according to the Rankine series we have been discussed, and tomorrow we'll be seeing how these stresses are going to be varies along the depth. But as of now, today I introduced the topic what is earth pressure and what is active state, passive state, and at rest earth pressure. So now with this, we can end up the session. So now those who are having a doubts, I'm going to take a doubt clearing session now, because so I don't want to go further. Whatever, this is nothing but the conditions. I hope you understood everything over here. So please go through the notes once again. By tomorrow, you please come with this. What is the active pressure formula, passive pressure formula? Tomorrow we are going to discuss a lot of things. So for this today, I'm stopping the session and I'll be enabling the doubt clearing session. Those who have doubts, you please raise your hands. We'll discuss now. So meanwhile, let's see. Mr. Kaushik, sorry, have cleared all the gaps and confusions I have. Thank you. Thank you, Kaushik. Sir, can tank foundations provide with top slab? Yes. If you provide a top slab, Mr. Ramit, that is an example of the rest condition. Sir, why you solved less questions on shear strength? I did not solve less questions on shear strength. I have solved more questions on the shear strength. On what basis we construct the wall as passive or active in the field, sir? See, that we will be knowing in a sheet pile. See, if you want to retain the soil mass more, then see, I'm sorry, I thought of showing you the sheet pile also, but did not. I'll show you now. You please look, have a look. Everybody, whatever. Yes, see, this is nothing but the sheet pile. Whatever this is nothing but the sheet piles. This is a soil mass, na? Whatever this is soil mass is a planar surface, and this is going to be the sheet pile. Okay, this is a sheet pile. Okay, I enable the raise hand option. Sorry, you're not telling about IIT since 1 week. Wait, Baba. Hate you, sir. You're not responding my questions. I love you to being hate me. Yes, those who wants to do, you can leave. Sir, sheet pile walls में active और passive pressure कैसे act करता है? ये देखो ना, ये देखो इधर. See, if the wall is moving away from the backfill, this is a wall moving away from the backfill. So away, then you are going to call it as active, and this is going to be towards, then this is going to be passive. And this condition is going to be attained only in the case of sheet pile walls, not on the ordinary retaining walls. So, sorry, if the confined pressure is kept to 0, that is for uniaxial compression, will the KF line passes through the origin? Yes, definitely, my dear. The KF line will passes through origin and it indicates the failure plane, then yes. So, no, my dear. So Sachin, please speak out.
No, sir.
Yeah, Sachin, tell me, Sachin.
Sir, can you hear me, sir?
Yeah, I'm hearing you.
Sir, one doubt, sir.
Yeah, tell me.
Can you please take the ESE previous year question chapter 3, sir?
Chapter?
3, sir. Soil structures and clay mineralogy.
Oh my God, you are asking us something which has happened 1 month back, huh?
I am now only attending doubt clearing sessions, sir.
Okay, fine. Yeah, which number, page number, can you please tell me?
In PDF 10th page, sir. Page number 10. Yes, sir. In third question, sir.
Predominant mineral. What is the question, Ray?
Sir, fourth question, sir. Sorry, sir. Fourth question.
Yeah, here, consider the following statements. A dispersive structure is formed. What is that? See, I explained this question in the classroom, Ray.
No, sir. One doubt, sir. You explained that remolding increases the void ratio and compaction decreases the void ratio, sir.
Very
But
good.
in
But I just want to say one thing. That's a dispersive structure, right?
yes, sir.
So in the case of the dispersive structure, if you see, when you compact the dispersive structure is on wet side or dry side?
The dispersive structure. Don't know, sir.
Remember the compaction curve?
Yes, sir.
Dry side and wet side?
Yes, sir. Yes, sir.
The dispersive structure will be occur on the dry side or wet side?
Dispersive structure.
Wet side. Dry side, flocculated structure. Wet side, dispersive structure.
Yes,
By
sir.
it reaches optimum, the void ratio is going to be very less or not?
Yes, sir.
And then see, the meaning of that one is, if the soil clay has a dispersive structure, it is on wet side, which means
Okay,
the void ratio has been reduced.
Okay, sir.
Understood?
Okay, sir.
Yeah.
So for dispersed structure, the void ratio should be high on compacting.
Yes.
Okay, sir. Sir, what is realizable friction ratio, sir?
Realizable friction ratio, that depends upon the sleeve friction, and that comes in cone penetration test, Nana.
Okay, sir. Here not required, no, sir.
No, it's not required now. You don't need to worry about it.
Sir, another doubt, sir. Sir, can you please take page number 13, sir? Page number 13, sir. 13, sir. Sir, in that fourth question, sir, I want a clarification in the question, sir.
The water content in percentage required to fully saturate the void ratio. That void ratio means no change in volume. What is the water content at which soil is fully saturated without any change in volume is shrinkage limit.
Sir, sorry, extremely sorry, sir. Third question, sir. I mistaken. Extremely sorry.
If the water table is very near to the subgrade, it will ultimately cause a cracking of the road surface, because if water table is going to be near, then the effect is going to be less. Yes.
Okay, sir.
That will easily causes less strength of the soil mass, and swelling would be happen. If water table is going to be very near, swelling would be happen. So the consistence of the soil changes from plastic to liquid state, leading to its volumetric decrease. Assertion is true.
Okay, sir.
But the plastic to liquid means the swelling is going to be happen or a shrinkage happens?
Swelling happens, sir.
Swelling means volume increase, right?
Increase. Yes, sir. Yes, sir.
Assertion is true, but reason is false.
Okay, sir. Sir, last doubt, sir. Can you please take page number 15, sir?
Yes.
In that 18th question, sir, with the addition of lime in soil,
Yes.
you told that the plasticity index will decrease. No, sir. Addition of lime, that lime treatment, black cotton soil in class, sir.
Yes. Yes. Yes.
Here options, I can't understand the options, sir.
That is PL means plastic limit.
Okay, sir.
Okay. So with addition of the lime in the soil mass.
Yes,
that,
sir.
Yeah. Listen. If the
Okay.
addition of the lime in the soil mass, what happens is clay will require more water to act like a plastic.
Okay, sir.
Which means plastic limit increases.
Okay, sir.
And within less time, it reaches to the liquid limit, which means liquid limit decreases. So with respect to that, the net plasticity index will be decreases.
Okay, sir.
So plastic limit, liquid limit increases, and plastic limit, liquid limit increases, and plastic limit are also going to be, actually liquid limit decrease. Yes, liquid limit and plastic limit both are going to be decreases. What is the answer? 18. Yeah, okay. They have given us very slight change. Yes. See that option C, liquid limit change very slightly means actually the meaning of that one is liquid limit decreases very slight. Decreases.
Okay, sir.
And plastic limit increases. Just now I told you, in order to make sure when you add a lime to the soil, it requires more amount of water to reach plastic. So plastic,
Yes,
plastic state won't come that much easily. So plastic limit increases, and the liquid limit is going to be slightly decreased, so that the IP value will be decreases.
Okay, sir.
That's option C.
Okay, sir.
Yeah.
Thank you so much, sir.
Yeah. Okay. Sir, can you give clarity on how many marks does GT take in GATE? Baba, 15 marks. And my dear Anonymous, that's highest weightage in the entire civil engineering. You are not going to see any subject near to that one also. The next subject is environmental engineering, 11 marks. But geotech, 15 marks. Let's see the next. Mr. Ryder. Mr. Ryder.
Hello.
Yeah, tell me.
Sir, GATE PDF, sir, GATE PDF. 6th chapter, permeability.
1-5.
Sir, what, sir?
Can you tell me which one?
GATE chapter, GATE PDF. 6th chapter, permeability. In GATE, sir.
Yeah. In which
6th chapter, permeability.
Page number, please.
Page number. Page number.
The page, tell me the page number. Yeah?
Wait, sir, 1 minute.
On the top, it would be there, na? Meanwhile, so please solve GATE 2 marks question number 18. Of
Page number 15, sir.
15, 1-5.
1-5.
For saying the page number, you took this much time, huh? Tell me, which question?
6th, sir, 6th.
That's see, the question is a wrong question. The question means in that the data required is not necessarily printed. It was wrong. Okay, so don't worry about that.
Okay, sir. 8th one question in that in the same chapter. 8th one question, 1 mark.
Yeah.
I didn't understand that question, sir.
An anisotropic soil deposit has coefficient of permeability in vertical and for constructing a flow net. Please go through the chapter number 9. There I said you, soil, if you want to construct a flow net, so how the horizontal dimension is going to be reduced by using a reduction coefficient root of ky by kx. Here, the y is given as z. Okay.
Yes, sir.
So root of k z by kx.
Okay.
Go
Okay.
through the notes once. Go through the notes. They have given
Thank you, sir.
kx is more than kz, root of kz by kx. Okay.
Okay, sir. Thank you. That's it, sir.
Yeah. Okay. Fine one. So now next gate 2 marks question number 18, sir. So now, sir, let's see, sir. What is that, sir? Question chapter 2 marks question number 18. Yes, that's a very good question. Actually, you can solve it, but fine. Yeah, this one also today. You please look over this question. So, my dear students, you please, those who are there here, please look over this question. Okay. Now, please observe this question. A conventional drained test is used, was conducted on a normally consolidated clay. So, conventional drained test. Drained test on NCC, you know it is going to be CC. The deviatoric stress at a effective confining pressure, which means effective means sigma 3 dash is equals to 200 kilopascals, and deviatoric stress is given as 400 kilopascals. 400 kilopascals. Now the specimen is going to be identical specimen. The specimen is going to be identical specimen. Now it is conducted on a same soil under a confining pressure. This is undrained. See, you know the meaning of drained means effective and undrained means total stress. So here the confining pressure, which means minor principal stress, is going to be same 200 kilopascals, and deviatoric stress at failure is given as 150 kilopascals. The pore water pressure developed would be. So my dear students, first of all, from the given data, you know, C dash is equals to 0. So now from drained test data, phi dash is equals to sine inverse of major minus minor by major plus minor. So dashes, yes. So I can write phi dash is equals to sine inverse of, what is the measure over here? Please tell me here. What is the measure? Then sigma 1 dash is equals to 200 plus 400, which is going to be 600 kilopascals. So 600 minus 200 by 600 plus 200. So which is going to be sine inverse of 600 minus 200 is 400. 400 by 800, 30 degrees. So phi dash is equals to 30 degrees. Now, isotropically consolidated means, what is the meaning of isotropically? In all the directions, so the consolidation pressure is going to be same. The meaning of hydrostatic pressure is isotropic condition or not. So now, for undrained test, you know, total stress analysis, you can write the effective stress is equals to total stress minus pore water pressure or not. So I want for the undrained test, I have the total stresses. Yes. So now phi dash is equals to same sine inverse of sigma 1 dash minus sigma 3 dash by sigma 1 dash plus sigma 3 dash. So now sine inverse of sigma 1 minus u minus sigma 3 minus u by sigma 1 minus u plus sigma 3 minus u. See, I'm just converting the effective stress in terms of total stress so that I can find out the pore water pressure. See, this u and this u will get cancelled. Then sine phi dash is equals to sigma 1 minus sigma 3 by sigma 1 plus sigma 3 minus 2u. So can you please tell me what is sigma 1 over here? Sigma 3 is equals to 200 kilopascals and sigma 1 is 200 plus 150, which is going to be 300 kilopascals. So now if you substitute this one, sine phi, sine 30 degrees is equals to sigma 1 350 minus 200 by 350 plus 200 minus 2u. So what is pore water pressure? What is pore water pressure? Come on, tell me now. So 350 minus 200, 150 into 2, 300, 550 minus answer by 2. So the value is going to be 125 kilopascals. This is the answer for the GATE question. GATE 2018. This is very, very good question actually. I hope you understood this. The person who has asked this, I'll be sharing this question because this question is very good question. Yes. So I hope you understood. First of all, from the data drained test, I have find out the phi dash. And from this question, I can write down this in terms of the total stress. Now, for the undrained test, the total stresses they have given. So now you apply the undrained test. The identical specimen means values are going to be same. So that's about this question. Now let's go for other question. So I'll do 135. And now let's see. Mr. White, 21L. Mr. White, 21L. Please raise your hand. Please speak out. Please speak out. Okay, fine. I hope for today, last call, Mr. HD.
Hello.
Yes, yes, tell me.
Hello, sir. I have a doubt in seepage analysis, previous gate questions. Page number 29.
Page number
29.
page number, question number.
8. Question number 8.
This is the question, right?
Question number 8, sir.
Two
No,
marks
two.
question.
Two mark section. 2 mark section.
Yes. Okay. This is the question. Last question, na?
So yeah, I got the answer 5, but it's showing 500.
See, they have asked in what units. You look over the units.
So I converted it to centimeter cube per second, but then too I'm getting 5 answer.
Number of drops are 10. Number of flow channels are 20.
Hmm.
And quotient of permeability of the soil is 3 mm per minute. So 3 mm per minute. And they're asking head loss as 5 meters. So Q in terms of centimeter cube per second per meter. Centimeter cube per second per meter. First you find out in terms of meter cube only, then last you can convert. So K 3 into mm 10 to the power of minus 3 into second means 60 into 5 into NF 20 by ND 10. Okay. So this is 2. 5 to 10. 5 to 10 and 10 100 to the 6 is 8. So this is going to be 1.8 into, that's it, right? Yeah, 1.8. And what is the units over here, please? What is the unit? Meter cube per second.
Meter cube per second.
Meter. So now they're asking in terms of centimeter cube per second per meter length of the dam. Yeah, 1.8 into 10 to the power of minus 6 centimeter cube per second per meter. That's it, right?
I once got this answer, but 500. Answer is showing 500. That's why.
Answer given is 500.
I first time did like you, then I converted directly K into centimeter per second and H into centimeter, and then
Minute only, right? Yes, minute. Let me check. Arey bhai, see, they have given per minute, right? Asking in terms of seconds, which is nothing but divided by 60, na? We had it as a multiply with 60, right? Conversion is wrong. If you want to convert the second into minute, you are going to multiply with 60, right?
Yes, sir.
Yes? This 3 into 10 to the power of minus 3 by 60. Yeah. Even I have done the wrong. 20 by 10. Now 10. Now it is going to be what is this value? 10. 10 gets cancelled. 1 by 5. 1 by 2.5 into 10 to the power of minus 3 meter cube per second per meter, 0.2 into 10 to the power of minus 3 into 10 to the power of 6, which means 500 centimeter cube per second per meter. Answer is 500 only.
Okay. And sir, one last doubt.
Yeah.
Sir, in permeability chapter, just a minute. Page number 17.
Page number
17, 17.
Tell me which question?
Question number 10.
What happened? That I already discussed in the classroom. You please go through that.
Okay, okay.
Okay.
Thank you.
Okay, with this, I am completing today's session. So, and one more, Miss Nikita. Question number 49 ES 11 chapter and 5th question in 12 chapter. 49 in 11 chapter. Exactly, 49 in 11 chapter, right? So. Okay, what happened over here? Yes. With that question you got. Okay. Corrosionless soil experiences a relatively quicker compression under load. Yes. Clay's compacted dry off optimum. See, I was about to look over this question. I did not see this question. This low stress range and high stress range, I have to verify that. Sai Nikita, I'll be letting you know tomorrow. Sorry for that today. I'll be letting to know you tomorrow. Next, last question. Fifth question in 12th chapter. Actually, here this question has a wrong answer. So, see, for the pneumatic type roller, all soils would be there, which means for this one, A should be 1. On smooth wheel roller, we go for 3. Sheet foot roller, we go for plastic soils of moderate cohesion. Actually, from the given options, we need to go. From the given options, we need to go like from the given options, if you observe, the pneumatic tire roller can be used for any soils here. You can use for the silty soils of low plasticity. No. Pneumatic tire roller will be for 1. Sheep foot roller for the plastic soils of moderate. So smooth wheel roller 3. And sheep foot roller would be 2. Vibrator roller is going to be silty soils of low plasticity. So 4. The answer should be this one, 1, 3, 2, 4. But the given options were not correct. So according to the options, we have to go. They have not given such type of answers at all. 1, 3, 2, 4. So from the given options, what we can do is, if you see, the pneumatic dry roller can be used for the silty soils of low plasticity, then you can go for the 3. Means from the given options, I am discussing this. From the given options, that is going to be there. But if you see the options, there is no option of A as 1. So the nearest answer is going to be silty soil. And for the smooth wheel roller, for the smooth wheel roller, you can go for the cohesive and granular soils also. And for sheep foot roller, definitely it is going to be plastic soil. And for vibratory roller, that's going to be cohesionless soil. From the given options, it is going to be A. but the actual answers would not be like that from the given codes. I don't know how the examiner has framed that question also, what he kept in mind. But that's all for today. So I'm leaving now. It's already been 1:45. Okay, I hope good day for all of you. So please go through the notes once again and start to do the questions.